Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Together we strive for a change through education. Ladies and gentlemen, today I want to take you through calculus for undergraduate, particularly for first year candidates. Under the calculus for first year, I will actually look at the following. We know that calculus has two subsections. Calculus for first year candidates, calculus for first years. Actually, calculus, it's divided into two parts. We have something called differential calculus, and also what is called the integration, which you call integral calculus. So we have differential calculus and something called the integral calculus. This one, like some of the content has been covered in grade 12, but this one is not yet covered, right? Under these two, we need to be able to differentiate between what is called the differential calculus and the integral calculus. Right, under the differential calculus, this is to do with finding or determining, finding the gradient of a function. It can either be a function or a curve at a point. Actually, the differential calculus, it's enabling us to find the gradient of a tangent or the gradient of a line that touches the curve at one point. So actually, this is to do with differential calculus. But however, under integration, this is to do with finding the area under the curve, the curve. But for a higher level of it, you can also determine the volume of a curve or of a function. For example, if you are given, let's say we're given the function or the curve in this fashion, I'll just say, let's say we have the following curve, and within this curve, there are points. This curve is bounded between A, which is an x value, and also B, and we're actually interested on the area bounded by this curve. So the area bounded by this curve. So in determining the area that is bounded by this curve, we can use what is something called integration. But it's not about the area only. We can also be able to determine the volume of a curve, and yes, bounded by that area, that curve. But that is to do with the multivariate integration. But in this part, particularly for part 1, I will focus on integration. Then in part 2, in the next video, I will focus on the differentiation, but in the next video, we'll focus on something called integral. Actually, integration is this has to do with the reverse. It is the reverse of differentiation. It is the reverse of differentiation. So if we are able to know how to differentiate in differential calculus, then the reverse process of it, that will become an integration, which we'll look on that later. Right, without wasting time, let's now start with differential calculus. We're going to start with differential calculus as part 1. Then in the next video, we'll also look on something called integration, which is called integral calculus. All right. Now, without wasting time, I just want us to look at this. If this is your first time watching my video, kindly don't forget to like, subscribe, and hit the bell button for future video notifications. Yes, let's start. Just a minute. And differential calculus, actually calculus is one of the most important topic in maths. It is widely used in the field of engineering, field of economics, field of, actually in most field of statistics, in calculating probabilities, they actually use differential calculus, right? Also in the field of machine learning, data science, and other fields, right? Without wasting time, let's now start. So we'll start with the differential calculus. The differential calculus. Right, under differential calculus for first year, number one, you need to have a pre-knowledge. The pre-knowledge of what you have learned in grade 12. Number one, in grade 12, you learned about the first principles. The first principles, where it says the f prime x is equal to the limit when h approaches 0 of f of x plus h minus f of x all over h. It's coming from the first principle. And now we can try to explain it further on why are they saying this is the formula for determining the first derivative from first principle. Let me try to do a summary on that. Right, remember from grade 12, we said when we have, let's say you have a curve that is bounded, let's say we have, this is the y and this is the x, and along this Cartesian plane there we have a curve. Let's call this curve f of x, and within this curve there is a line that will touch the curve. Okay, let me just draw. Let's say there's a line that is there. We draw a line that touches the curve twice. Okay, let's say we have a line there, and this line touches the curve at point A, and also at point B. So now let's call this, we know that a line that touches the curve more than once is called a secant. Now we can easily see that within this secants that have touched the curve more than once, there's a point here. So let's assume this point here, its value is x1, and also the point B here, its x value is x2, which means that if we know the value of x here and the value of x2 and x1, we can be able to determine the y value on both the a and the b. And how to do that? It means now, as the function, it means our function is f of x. So since we know that x1 is the input, so it means the output will be f of x1. So it means this point here, the point here would have this point here, this point exactly here, this will be the f of x2, this would be f of x1. And same applies when our x is x2, that means the y will be f of x2. Obviously, it means this we can denote it as y1, and this one we can denote it as y2. So in other words, in finding the gradient of a secant, if you wanted to calculate the gradient of a secant AB, it means we'll have to use an average gradient formula that says the gradient is y2 minus y1 over x2 minus x1, which is what we have done now. Now, so it means it is easier to actually calculate the gradient between 2 points. But the question is, what if this time around we no longer have x1 and x2? We no longer have x1 and x2. This time around, what we have is just the x. So this time around, what we have, let me just use a different, let's say we have x, and now we increase this x by a certain delta, let's call it h, increase by h, so it means the next value will be x plus h. So it means now, if we know this is x, it means when we put inside the function, this will be f of x. Same applies, this one will be, this point, it will be f of x plus h. So which means in calculating the gradient again of the secant with those points, then we'll say, okay, fine. We know that the gradient of AB, which is our secant, is y2 minus y1. And remember, our y2 is this one, our y1 is this one. So it means what is our y2? Y2 will be f of x plus h minus y1 would be f of x all over x2. X2, it means this will be the x1 and this will be the x2. So this will be x plus h minus the x. And it means the end result will be f of x plus h minus f of x all over h. So this is the formula for calculating the gradient of a secant. But now, under differential calculus, we are not interested in calculating the gradient of a secant. We are interested in calculating the gradient of a tangent. The gradient of a tangent, because a tangent is the line that touches the curve at one point. So what does this mean? It means on the same curve that we're having, if we can now draw a line that touches that curve at a point, there is the line. So it means now, what do you want to do? You want to now calculate the gradient of a tangent, not of a secant, because with the secant, there are 2 points. So it means with the tangent, we now want to approximate, actually wanted to calculate, to come up with the formula of calculating the gradient of a tangent. And to do so, it means we can approximate that by using the gradient of a secant. And how can we do that? It means the only way we can be able to use the gradient of the secant such that we end up having the gradient of a tangent is to have a control towards something called h. We need to control this h. How can we control the h? Remember we said if we have x here and we increase the value of x by h, it means the next value will be x plus h. So it means now, what can we do? We can say, okay, fine. If we do the control towards it, it's okay, fine. Let's assume now h is 0.1. Is this an example? So if we have these values of x, maybe we have the first value of x is 2, then it means the next value will be, when you increase it by h, it will be 2.1. So it means, by so doing, it means once we keep on controlling this h, let's say we want this h to be closer and closer to 0. So it means we reduce this h up until it becomes closer and closer to 0. So let's say we keep on, this becomes 0.01, 0.001, and so forth. It means the more we do that, means this line of a secant will come closer and closer. Ultimately, the secant will now become a tangent. So it means now we will introduce something called limit to say, in order to approximate the gradient of a tangent, we'll have to control the h on the gradient of a secant, to say the limit when h approaches 0, not equals to 0, but approaches 0, the gradient of a secant AB, the gradient of a secant AB will ultimately become the gradient of a tangent if we control the gradient of a secant. That's why, as a result, we'll end up having the limit when h approaches 0. What is the gradient of a secant? The gradient of a secant is f of x plus h minus f of x over h. That's why this formula for first principle is coming from that. So which means we'll say, because now we want the gradient of a tangent at the point, then we now introduce the limit when h approaches 0 on delta y over delta x. So it means this can be approximated as dy over dx. And this dy over dx is the same as f prime x, which has to do with the first derivative. It's called the first derivative, which is used to calculate the gradient at a point. That's why now we know that when we change this, this will now become f prime x equals to the limit, and this is called the f prime x from first principle. This is what we have learned in grade 12, ladies and gentlemen. So we need to also be able to understand this, right? And again, secondly, You must also be acquainted with the rules of differentiation, the ones you learned in grade 12, beside first principle. Remember, the objective of f prime x is to determine the gradient of a tangent, or the gradient at a point, which I just addressed now. So it means now you need to also understand how to actually use this f prime x, which is the first derivative, which is used to calculate the gradient of a curve or of a function at a point, ladies and gentlemen. Okay, let me just try to erase this one. Secondly, you need to be able to understand how to find the derivative using something called the rules of differentiation. This is grade 12 work, the rules of differentiation. Let me address that. The rules of differentiation, that's number 2. So number 2, it means you need to understand the rules of differentiation. The rules of differentiation. Under the rules of differentiation, rule number 1 says, if you have y equals to x to the power of n, then in determining the derivative of y with respect to x, so we're differentiating y, but interested on x. This is the same as nx raised to the power of n minus 1. This is very, 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 very important. This is what you have learned in grade 12. For example, if you have y equals to x to the power of 3, so it means the derivative of y with respect to x, this will be 3x to the power of 3 minus 1. This will give us 3x squared. So this is the gradient function. Then secondly, you need to be able to know that when we have y equals to kx, where k is a constant, let's differentiate y with respect to x. So the derivative of y with respect to x, this will give us k. The answer will just be k. Why? Because when we have y equals to kx, we want to differentiate y with respect to x. The power is 1. So we're going to use this rule to say the n must come down reduced by 1. So this will become k multiplied by 1 into x to the power of 1 minus 1. And this will become k to the exponent of 0. And we know that any number, the exponent of 0, it's 1. So this becomes k times 1, which is just k. So it means the derivative of kx is just k. Then the third one is the issue of when you are given y equals to k alone, where k is constant, then to determine y, derivative of y with respect to x. And since there is no x here, it means this is now a constant. So in the derivative of a constant, it's always 0. We have learned this in grade 12, derivative of a constant. It's 0, derivative of a constant. It's 0. So these are very, very, very important for you to know, to understand the first year differential calculus, ladies and gentlemen. The other one that I strongly believe you must also understand it is the issue of concavity under curve sketching. The issue of concavity. You must also remember the properties of concavity under curve sketching, which I will address here, because we'll be using these in the next coming slide, and you need to also understand what I'm actually saying here. Right. Let's talk about the principles of concavity. Then we'll move on to the key concepts for first year differential calculus. So this is just a pre-knowledge, which I strongly believe everyone understand. All right. Number 3, under the pre-knowledge, you need to understand concavity. Concavity, and also testing whether in terms of the curve, if you have a local maximum turning point or minimum, where we use something called second derivative test. Second derivative test. Right, let's assume we have a curve like this. Obvious, a curve like this is a cubic function. And we know cubic function in terms of the standard form, it's written in the form of ax cubic plus bx squared plus cx plus d. And we know very well that when the a its number bigger than 0, the graph must have a sad face followed by a smile face. Okay, right. which we're gonna talk about that. Then now, in terms of this, we want to actually understand what is this concavity on the cubic function. Right, if you look at the on this cubic function, there are points. For example, if you look at this point, this is the turning point of the cubic function, and also this is the turning point. But this we're gonna call it a local maximum turning point, and this is the local minimum turning point. And in reality, where the graph is actually turning, its gradient is always 0. The graph where it is actually turning, the gradient is always 0. So it means where the graph is turning, we must always ensure that the gradient at that point is always 0. And when you talk about gradient in calculus, you're referring to the f prime x, the derivative of a function at the point. It should be 0. That's why if you recall from functions and graphs, if you recall this function, like where we said, like when we have y equals to ax squared plus bx plus c, how do we actually find the turning point of a cubic, of a parabola? Usually you recall that first of all, you must get something called axis of symmetry. And at the axis of symmetry, that's what we use x equals to minus b over 2a. Now the question is, why are we using x equals to minus b over 2a? Here is the reason, is the answer. It's because when you have a parabola, the parabola, most of parabola has the turning point. Either when a is negative or when a is positive, they have turning points. And we know where the graph is actually turning, its gradient, it's always 0. And when you talk about in calculus, when you're referring to a gradient at the point, you're referring to derivative. So it means if you take this function and we differentiate this function with respect to x and equate this to 0, let's do the derivative using all like those rules that I said there. So this will become 2ax 2 minus 1 plus this is kx, will just be b here, and this constant is 0. So if we equate this will give us 2ax plus b equals to 0. Let's solve for x. 2ax equals to minus b. Let's divide by 2a, and the x will become negative b over 2a. That's why we're using that axis of symmetry, because of calculus. So it's very important to be able to understand the applications of calculus. Is very important. Right, which means that we can say now, here we want to actually talk about concavity of a function. The concavity of a function actually applies to cases where the graph changes from a maximum turning point to a minimum turning point, or from a minimum turning point to a maximum turning point in terms of its concavity. So what does this mean? Now look at this. If we have, let's say we have a point here. Let's say we have a point somewhere here. And we know a value of x at that point. So do you see that anything less than that value of x, this actually gives us, it actually gives us something called concave, this becomes a concave down. So this gives us concave down, and this become concave up. You see that if we are able to tell the value of x which changes its concavity. So it means you can be able to tell that when x is bigger than that value or is bigger than, then we have concave up or concave down. This is we use something called second derivative test to actually check for concavity. Because concavity has to do with parabola, to say, we know that on a parabola, when a is bigger than 0, the parabolic graph has a smile face. And when a is less than 0, a parabola has a what? A sad face. You see, when on a parabola, when a is positive, it means the parabola gives us something called concave up. And this one gives us concave down. So it means when we have a concave up, the turning point of that parabola, it's called a minimum turning point. It's at the minimum. But when it's having concave down, then the turning point, it is at its peak, at its maximum. Hence, this one we're going to call it a local maximum and local minimum turning points. And why do we call them the local minimum and local maximum? Because this curve might have its maximum turning point except this one. So that's why we said you might find that it's not the only maximum turning point that the curve can have. So you need to be able to use something called second derivative test. So it means you have to differentiate for the second time. But there are conditions. Number one, if the second derivative is bigger than 0, 2, or the second derivative, it's exactly equals to 0. 3, or the second derivative, it's now less than 0. You need to understand the following. When the second derivative is bigger than 0, you must know that you are dealing with concave up. And remember, where there is a concave up, remember I said we will always have a what? A minimum turning point. So in other words, if you calculate the turning point of a cubic function and you wanted to check which one will be at its maximum and which one will be at its minimum, you have to use second derivative test. If the second derivative test of the turning point that you calculated, you substituted, it's giving us a positive answer, you must know that that turning point will be at the minimum because it's giving us a concave up. But when the second derivative is exactly equals to 0, we have something called the point of inflection. And what do you mean by this point of inflection? There is an example which I actually addressed here. Point of inflection is the point where the curve or the graph changes its concavity from concave up to concave down or concave down to concave up. So when we know the value of x for the point of inflation, we can easily tell whether the graph is concave down or concave up. So this is the point where the graph changes its concavity. But when the second derivative is less than 0, you must know that you are going to have a concave down. And listen, where there is a concave down, it means the turning point, the local turning point will be at its maximum. You will have the local maximum turning point. And how can you easily remember this? Let's say you want to remember this. You can easily remember these two properties by thinking of parabola. This, whatever I've addressed. Remember we said on a parabola, when the A is positive on the parabola, the graph of a parabola smiles. But when A is negative on the parabola, the graph have a sad face. And when the graph has a sad face, it means we have a concave down. And when the graph has a smile face, it means we have concave up. And look, concave up occurs on a parabola when A is positive. So it means what you can do, you can just, if you want to remember this, when you know A is positive, you can replace this with the second derivative. We'll get that. But when A is negative, you replace that with the second. So you see that concave down will give you this, concave up will give you that. So this is what we'll be using also under the calculus for first year university. So you need to be able to differentiate between concavity in terms of second derivative test and also be able to identify where do we have a point of inflation. Very, 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 very important. And this is what is widely used. It is widely used in the field of engineering, statistics, and other fields. So you need to be able to understand this, ladies and gentlemen. I believe you are following. I strongly believe you are following, ladies and gentlemen. So this is what, it's a pre-knowledge. You're expected to know everything that I just explained here in order to understand your first year university differential calculus. Okay, then now let's move on to one of the slides from the university. I'll just go through the slide, ladies and gentlemen, maybe with few additions, but it's not my own slides. It's from one of the doctors. So I just got this, just to use it in order to share some most important aspects towards differential calculus. I strongly believe you will enjoy the session. Let me now try to share the slide. Okay. Right, now here I'm just focusing through the differential calculus, which is chapter 2 from the University of Venda by Dr. R. Netshikweta and B. Maregere. This is for Maths 1143 and 1543. I did not school at University of Venda, so I just want to go through these slides because I believe this is the relevant one, particularly for first year candidate. And yeah, you see, it shows that this is the first semester Maths, and this was implemented in 2023. I'll just go through the slides with you, ladies and gentlemen. I strongly believe you will enjoy. Right, according to the slides, it's showing the objective of this session. The objective of this session is to introduce techniques called differentiation for calculating the gradient of a curve at a point. I think I've already addressed this to say differential calculus is there to calculate the gradient at a point. I strongly believe you are now following. And again, also introduce some rules for finding the gradient functions, like the rules of differentiation, which are actually addressed. And also you must explain what is meant by the term first derivative, the f prime x or dy over dx, which is the derivative of y with respect to x, which is in other book, we call it the rate of change of one variable with respect to another. And also you need to be able to know the second derivative test, which can also be written as d squared y over dx squared. So this also has to do with second derivative. So this is the second derivative. But in third years, you'll now be talking about the third derivative, the highest order derivative. So it's very important to also understand this. And again, you need to be able to explain the term maximum and the minimum when you apply to function. Like what I said, concave up and concave down has a minimum turning points and the maximum turning points. And now, for example, if we were to talk about in economics, we have something called business cycles. Then under business cycle, we know we have a peak and we have a trough. You see, this is almost like a minimum, a maximum, and this is the minimum. So you need to be able to understand that. Again, you need to also apply the techniques of differentiation to locating the maximum and the minimum value of a function. Like what I said, that you must be able to tell which point is at the maximum and which one is at the minimum by looking at the second derivative test, which is called concavity, or second derivative test. Right, let us now proceed. Then this is the learning objective. Right, when you move on, here is just an overview of differential calculus, like what they've said according to the doctors. Now, they said differential calculus along with integral calculus are two branches of calculus. I think I've explained this earlier to say calculus is divided into two branches. First one is differential, and the other one is an integral calculus. Right, and the study of continuous change or the rate of function. So it's just explaining how to calculate, like it's studying the differential actually focus on how to determine the change or the rate of change of a function. And again, calculus was developed by Newton. You know, Newton also done the laws in physics, and also Leibniz to deal with finding the different properties of derivative and also the integrals of a function. This is just an overview according to what the doctors have said. And again, without wasting time, differential calculus deals with what you call the rate of a change of one quantity with respect to another, like what I said, that changes in volume with respect to radius, changes in y with respect to x. This to do with the gradient, the rate of change. Remember, in maths, usually in physics, when you use the word rate, it has to do with time, change in y over change in t. But in maths, we can look at the changes in y with respect to x, any variable. So this has to do with differential calculus, the rate of change of one quantity with respect to another quantity. And again, we have what is this? Like according to, they said this semester will only deal with differential calculus, while in the second semester they will focus on integration, which is there to calculate the area bounded between two curves, between two points on a curve. And actually to emphasize the issue of differential calculus, imagine we are having, let's say we're given this function, let's say we're having v equals to 4/3 pi r cubic, which is called the volume of a sphere. This is the volume of a sphere. Then imagine in the paper or in the exam, they say, determine the rate of change in volume. Determine the rate of change in volume with respect to its radius. So here we wanted to know what is the rate of the change in volume with respect to its radius. See, now it means this is differential calculus to say we want the change in volume with respect to the change in the radius. You see, this is differential calculus. It's the same as v prime of r. So it's a first derivative to say you have to differentiate the volume by looking at r, which require the rules of differentiation, what you learned in grade 11, to say this is the same as the n will come down. This will be 4/3 multiplied by 3 into pi r to the power of 3 minus 1. And this will give us 4 pi r squared. And if you recall very well, the 4 pi r squared, it's actually called the surface area of a sphere. Surface area of a sphere. Surface area of a sphere. Very, 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 very important. For example, if we are given, what is this? The area of a circle, we know area of a circle, it's pi r squared. And we can say, what is the rate of change in area with respect to the radius? This is to do with differential calculus, to say, we want to make a derivative of the area, but interested on R. So we're going to use the rules of differentiation. We're going to say 2 pi R 2 minus 1, which will just become 2 pi R. And if you recall, 2 pi R, it's actually the circumference. It's actually the circumference of a circle. It's actually the circumference of a circle. It's actually the circumference of the circle. So it's very, 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 very important to be able to understand how to deal with differential equations. So it means, I'm saying calculus. So it means under differential calculus, we're interested on determining the rate of change of one quantity with respect to another quantity, which has to do with finding the gradient function or finding the gradient at a point, ladies and gentlemen. Very, 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 very important. Right, let's now move on to the next slide of this document. Right, moving on, let's move on to the next slide. Overview of differential calculus, gradient of a curve. Like what I said, the gradient of a straight line is constant. The gradient of a line is constant and simply determined by dy over dx. Why dy over dx? It means you are talking about a line, and that's just saying the gradient of a line, it's a constant. And if we simply determine by using dy over dx, which this has to do with the average gradient, this has to do with the average gradient. And this average gradient is the ratio between 2 points on the line. Remember we said the gradient, average gradient has to do with seconds, where we say y2 minus y1 over x2 minus x1. So it means in determining the gradient of a secant, we just use the average gradient. I strongly believe you're following. But according to this, they said, but on the curve, the gradient is changing from one point to another. And it's true. Imagine when we have this, let's say we have a curve here. If I draw a line that touches the curve here, let's call this secant number 1. You see that the gradient of this line might actually change. If we change the, like, let's say I draw another one, you see, or I constantly, you see that their gradient will actually be different. They will now become different. So it means the gradient on the curve, on the curve, the gradient is changing from one point to another. Once we change a point, it means its average gradient actually changes. That is what they're actually saying. And according to this, they're saying thus we can define the gradient at any point. You see, at any point on the curve to be the gradient of a tangent to the curve at that point. So it means now they're actually saying when we have a curve, if we draw a line that touches the curve at one point, how can we calculate the gradient? So it means now to calculate the gradient at a point is the same as when you're calculating the gradient of a tangent at that point. And that's where differential calculus comes into play, according to what I explained earlier. I strongly believe you are following. Then now, according to this, it says, recall that a tangent to the curve is a straight line, because a tangent is just a line that touches the curve at one point, which is true. Then now, that touches the curve at a point. I think I've explained that. So to find the gradient at any point on the curve, we can make use of the method. Which method? The method of limiting process. To say we can use the gradient of a secant to approximate the gradient of a tangent. We can use the gradient of a secant to approximate the gradient of a secant by using something called the limiting process, like what I said. And this limiting process sometimes is known as differentiation from first principle. You see, it's what we have covered in grade 12. I think I have explained that. So we can move on. We can now move on to the next slide. So this is just an overview to actually acquaint you, actually bring back what you have done actually in grade 12, and also so that you can be able to understand your first year university calculus. And then now we move on to something called increments. Increments in your syllabus, this has to do with starting with, like, if you recall from my diagram initial, I said, if you have a curve of this nature, let's say this is the x and the y, and you draw a curve along this, let's say there is a curve, and this curve there's a line, then let's call this there's a point x, and we increase this value of x by a certain value, which we call it h. This has to do with increment, because we're increasing this value. This will be x plus h. So we are doing an increment. So then, which means within this, we are going to talk about, we started at x, now we are moving at x plus h. So what is our increment? Our increment now will be the h in terms of what I've learned. But if you can look at the same definition, let the variable x have the first value called x1. So we are letting the variable x to have x value, which is called x1. That's our x1. That's our x1 here. Then the value of x become x1. Then they say the second value, which is x2, that's our x2. There is our x2. Then the change in value of x will be x2 minus x1, because we want the change in x. And this change in x will give us x2 minus x1. So now what does this mean? It means that when we call it the increment in x, we call it delta x. So it's the same as what we said. Imagine we want to calculate what is your x2 here. It means your x2 will be x1 plus delta x, which will give us x2. So it means the only difference is the same. Here we use the h. Now they're replacing h with x2. It's one and the same thing. It is one and the same thing, because on our side, if we say wanted delta x, this will be x2 minus x1. What is the x2? X plus h. X1 will be the x. So you see that our delta x will now be h. So it means now in grade 12 we use the h, but this time around they're using delta x, which is one the same thing. It is one and the same thing. So which means if we were to apply this formally, so from the first principle formula, because I strongly believe it is what they want us to achieve here. So let's recall the first principle formula or the average gradient. If we say we have f of x plus h minus f of x all over the h. So if we replace this h with delta x, it means it will still be the same thing. It's x plus delta x minus f of x all over. You see, it's one and the same thing, just that now instead of using h, they're using delta x. They're using delta x, which is the change in the y value. So this is what they're actually saying there. Right? Oh, actually, it's the change in y, not the change in x. Right, then now, if we move on here, according to what they said, okay, fine. Let f of x, when x be the value x1, and y, the y will have y equals to f of x1. Similarly, when x has value of x2, the y will have this. I think there's a typo here. There's a typo here. This is supposed to be y2. Then now, the increment in y will be this. The increment, which is y2 minus y1, it will be f of x1 with delta x minus that. What does this mean? Let me try to explain this according to what they're actually saying. They're saying, consider you have the same curve here. And this curve, let's say you have a curve, and you call this point here, you call this point the x, which will assume it's our x1. If we increase this value of x by delta x, it means the new value here will be x plus delta x, like x plus h. So it means when we input this into the function, this will be f of x plus delta x, and this will be the f of x. And since we say this is x1, it means this will be x2, and this will be y1, and this will be y2. So it means just to get delta y alone, the delta y, change in y alone, this will be y2 minus y1. So actually I want to explain this to say the gradient is changing y over changing x, but we are starting with the numerator. So this will be, what is the y2? The y2 would be f of x plus delta x, or not over, minus f of x. So this is what they're actually trying to explain here. It's just that they mix delta x. So now you see that it's still the same thing here. Now here they said, okay, fine, we know this is y. We know this is just y, a mere y. So it means we can say, because we know it's delta y equals to f of x plus delta x minus the y. We can take this on that side. This will be y plus delta y equals to the f of x plus delta x, which is the same as the h that we used in grade 12. This is what they're actually trying to explain here. I strongly believe you are following, ladies and gentlemen. I strongly believe you are following. All right, let's now proceed. Let's now proceed with the lecture notes. Okay, and now, same in the context of increment, here they're saying when we are given f of x, which is equals to x squared, we are given f of x, which is equals to x squared. There's no need to draw, but I can draw it, but there's no need. That's our f of x. And within this y equals to f of x, it says find delta y, changes in y, if x equals to 1 and the delta x is 0,2. What does this mean? It means now we're going to do this to say, within the curve, we have this. We have the first value of x. Let's call this x1, which is 1. Then we increase this value of x by 0,2. So it means the next value will now be 1 plus 0,2, which is 1,2, which will be the x2. So now the question, it says we have to find delta y. And how do we find delta y, guys? Remember here, we know, recall from what you have learned from average gradient, f of x plus h minus f of x all over h. Remember, this is the delta y. This is the delta x. So which means that delta y here would be delta y would be f of x plus, instead of using h, we'll use delta x minus f of x. Let's now do the substitution. So it means now the delta y would be, what is the x value? The x is 1. So we're going to input 1 here. X is 1. Then delta x would be 0,2. So if it's 0,2, it means this one will become 1.2 minus f of, what is the x? The x would be 1. So it means we want to calculate f of 1.2 minus 1. And what is f of 1.2? We have the function is this one. So it means where there is x, we'll put 1.2. So this will be 1.2 squared minus 1 squared. And we can now get the answer. And this will be 1.2 squared minus 1 squared, which will just be 0.44. 0.44. So this is what they're actually saying. So it means the delta y would be 0.44. You see, f of x plus delta x minus, so which is replaced by h in terms of principles. Okay. All right. Let's move on to the next question. I think here there's a typo. It's supposed to be delta x. Then now, let's move on to the next question. So you see, the answer now is becoming 0.2. And they're actually saying that for the function y equals to x squared, delta y can be found, like if you were to get the general formula when we have that, we can also get it in that fashion to say, we know that when we have delta y. Delta y is f of x plus delta x minus f of x. But we know that f of x is just x squared. And what is f of x plus delta x? Like f of x plus h, like what you learned in grade 12. This become x bar plus delta x squared. Then this is just mere algebra. So you can expand this, and this will give you x squared plus 2x delta x plus the delta x squared. So when we substitute here, this will give us x squared plus 2x delta x plus delta x squared minus what is the x squared is just f of x squared. You see, this will become 0. Then we'll ultimately have 2x delta x plus delta x squared. So it means in terms of our calculation, if we can now say we have the value of x, so it's delta y, we have the value of x, it's 1. Let's substitute by, so this will be 2 times 1, delta x is 0.2 plus delta x is 0.2, but we're going to square it. So this will still going to give us 0.44 as the answer. It will still give us the same answer. This is what they're actually explaining here, ladies and gentlemen. I believe you are following. I strongly believe you're following. All right, let's now move on to the next slide. We'll move on to the next slide. In the next slide, they're saying it's just an example. It's just an example. Okay, they're saying the size of an insect. The size of an insect population at time t is measured in days. So it means now we have an insect population which is measured in days in terms of time. So it's given by this. F is the population of insect. T is the time that is measured in what? In days. Right. According to this, they're saying determine the change in population. Determine the change in population. So we want to look at the changes in population when t is equals to 2 and the delta t equals to 3. What does this mean? It means now you're going to say, we're going to use this to say, okay, we know changes in y would be f of x plus delta x minus f of x. Now we are dealing, this is a function of t, which means the changes in f of t, which is the y, this will be f of t plus delta t minus f of t, because this is a function of t. And which means that changes in population as a function of time would be, what is the t? The t is 2. So if we put 2 there and we add 2 by the increment, which is 3 minus f of the t is 2, which means we want to calculate f at 5 minus f at 2. And since we are given a function, ladies and gentlemen, this is the function. So what does it mean? It means we can calculate f at 5 and f at 2 by substituting where there is t here by 5 initial. So we're going to put 5 here and 5 there. So obvious, we're going to say delta f of t, or the changes in f, when we put 2 here, this would be, we substitute by 5. So this will be 5,000 minus the fraction 3,000 divided by 1 plus 5, which is just be 6. So let's get the answer. The first one is giving us 4,500. What does this mean? F at 5 is 4,500 minus, we do the same when t is 2. So it's going to be 1 plus 2, which is just 3. Then this gives us 4,000. So it means now you're going to say 4,500 minus 4,000. This will just be 5. So it means that the changes in population at t equals to 2, it changed by 500. Very important. This is what they're actually trying to say in terms of this. So it's very important to understand that. Okay, let's now move on to the next example. Okay. So if you can check, you see, they're just doing what I'm actually saying here. To say you substitute, then the population increases by 500 during the 3 days that follow the second day, which is the answer there. Right, let's now move on to the rates. So it's what I was just explaining. Now it says the average rate of change of a function f over an interval x to x plus delta x is defined by this. You see this, the only difference from this, that from what you learn in grade 12, delta y over delta x, it's f of x plus h minus f of x all over h. Just that this time around they're using delta x instead of h, which is an average gradient. So I strongly believe you are following. I'm not going to put more effort on this because I have explained it thoroughly. So then there's an example. It says now it says a population of bacteria is introduced to a nutrient medium, and suppose that the weight of population in milligrams. So it means the population is in milligram. It is in milligram, and changes according to the following formula. We are given the formula for a population, where t is the time in hours. So it means the population is a function of t, and this t is a time in hours. Okay, then it says determine the average growth of population during the 5-hour period that is starting in 2 hours. During the first hour period starting in 2 hours. So now here, we don't want to calculate the average, the change in population. We want to calculate the average rate of change. So it means to calculate the average rate of change in population, it means you're going to look at this is the changes in population over changes in time. But according to the formula, we know that delta y over delta x, it's f of x plus delta x minus f of x over h, because it's over delta x, I apologize, over delta x. So it means the only difference we're going to say p of, because the function of t is going to be t plus delta t minus p of t over delta t. So it's just the difference here using f, that is replaced by t, delta t, and so on. So now we're going to do this. We're going to say, okay, fine. We want to calculate the average change in population, the average change of the population during the 5 hour, starting in t. So it means the starting point, the t is 2, but the delta t, not delta x. Delta t, it's the increment actually. The delta t, it's 5. So we're going to substitute where there is, this will give us, if you put 2 there, we put 5. This will be 2 plus 5, this is 7, minus p at, we put 2, this will be p at 2 over, what is the delta t? Delta t, it's 5. So what we're going to do here, ladies and gentlemen, we're going to say, okay, fine. We have to calculate p at 7. So it means where there is t, we put 7 there. So this would be 50 minus fraction 100 times 7 divided by 21 plus 7 squared. And this will give us 40. So this will have 40 minus. We do the same for substituting by 2 there, and 2 there. And this will give us 42 over, what is the change in time? The change in time would be 5. So 40 minus 42 divided by 5, it means this will change at the rate of -4, but remember it's milligram per hour, which is the answer, milligram per hour. But remember, there are many ways to skin a cat. One can also do this, can say, okay, fine. Since we're having the starting point is T, let's call this T1, and this one is T2. But from here to here, there's a gap of 5. So if we say this is 2, increase, this will be 7. So you see that by using this, we have T1 and T2. So it means you can say the change in Y over change in T, which you can call it Y2 minus Y1 over T2 minus T1. Then the Y2 would be this one, like the value of Y corresponding to this. It means whether we substitute by 7, then that will give us 40. It will still give us the same. It's going to be 40 minus 42 over 7 minus 2, which will still give us the same as average gradient. So there's no problem with that. I believe you are following. Ladies and gentlemen, I believe we are following. So it shows that the average rate of growth of population of these bacteria, it's 0.4. So it means it shows that it's decreasing at that rate. That represents a decreasing rate, actually. It's not an increasing rate according to this. Right. You see, that is what they've done. I think there's a typo here. There's a typo. This is supposed to be minus P of T. Minus P of T. So that when you put, you see, it becomes that. Then there's the answer, ladies and gentlemen. Okay. Now let's move on. 50 minus, what is this, 200 over 25. Yes, there's a typo also, yeah? It's just a typo. This is to be 42, not 50. Okay, then now we can move on. Limits and continuity. This is very important. Limits and continuity. The limits in maths are defined as the value that a function says f approaches the output for a given input. And this limit plays a vital role in calculus and in mathematical analysis. For example, the definition of the limit actually in terms of its application, it works like this. So when we have the following, let's say you have in terms of this, it says the limit when you have the limit when x, let's say, approaches L of f of x. This gives us L. This is the definition of a limit that says the limit when x approaches A, f of x becomes L. So the limit as x approaches A, or the limit when x approaches A, then the f of x becomes L, or f of x equals to L. And this is very, very important. But in particular, I used to define concept as a continuity, which will explain derivatives and integrals. Okay, worth mentioning that limits are unique real numbers, very important. Mathematically, a limit of a real value function f, if given a real number c, is defined in this form. So it is what I was actually explaining there. So in terms of the limits, in terms of its application. Right, to say, when you are given a limit, definition of a limit, to say, the limit when x approaches c, f of x becomes L. So it reads as the limit of f of x as x approaches c, then f of x equals to L. The limit shows that. So it means the limit when x approaches c, when x approaches c, f of x will be equals to L. F of x will be equals to L. I apologize. When x approaches c, the limit as x approaches c, f of x will be equals to L. That is according to the definition of limits. Very important. Very, very, very important. Like what we said in terms of first principle, to say the limit when h approaches 0, the limit as h approaches 0, the gradient of a secant, the gradient of a secant will now become the gradient of a tangent. The limit when h approaches 0, the f of x plus h minus f of x will be equals to the gradient of the tangent, which is f prime x. Very important. Very, 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 very important. Okay, let's now move on. This is just an introduction of limits. All right, limit and continuity. Let's continue with the continuity, limit and continuity. Okay, right. Properties of limits, and this is very important. You need to be able to know the properties of limits. Law of limit, the first one says the sum of limits, the sum, remember the sum of function on limit is the same as limit sum, is the same as the limit sum. So you can split, when you have the limit of f of x plus g is the same as calculate the limit of f alone and the limit of g alone. Same applies with the limit of subtraction, same applies. For multiplication, same applies, you can multiply. Then the limit of division, there's a condition says, when you have the limit when x approaches c of f of x divided by g of x, this can be splitted separately to say the limit when x approaches c, I think, yeah, it's supposed to be a c, but it's fine. It's supposed to be a C, with the C supposed to be C instead of A. But it makes sense, it's fine. Right, then now, with this, ladies and gentlemen, if this is the case, it means this can be done separately, but there's a condition to say the limit of the denominator should not be 0. And it's true because remember, any number or any expression divided by 0, it will become undefined. That's why they're saying the denominator should not be equals to 0. I strongly believe you are following. The denominator shouldn't be equals to 0. Okay? All right. We move on, ladies and gentlemen. Then the other one is the issue of the law of constant multiple, to say the limit when x approaches 0 of k of f of x. What we can do, we can just pull the k out. We can just pull the k out. This becomes k, the limit of the expression. So you need to be able to know these limits in terms when you're going to solve examples. So this is just an overview. Let's now proceed. Right, here is an example. It says the limits of polynomial functions. So polynomial function that has many terms. Right, if you look at this, it says that the limit when x approaches c, the limit when x approaches c of this function. So it means according to the definition of limit, this is the limit sum and subtraction. So we can split, we can calculate the limit of this one, limit of that separate, and the limit. So we can separate them. And after separating them, then we do the direct substitution to say where there is x, we substitute by c. This becomes cubic. It's a cubic, supposed to say c cubic plus 4c squared minus 3. So we can also do something called direct substitution. To say where there is c, where there is x, we substitute by c. And it will give us c cubic plus 4c squared minus 3. Same applies with the division. Same applies with the division. It's very important. Same applies with the division, ladies and gentlemen. Under division, it means we can still split the expression to say when we have the limit or when x approaches c of the numerator and the denominator, what we can do, we can apply the limit on the numerator alone and also apply the limit on the denominator. And we can even split one by one also. It's also applicable there. Okay, I apologize, guys. So as I was saying that we can split the limit one by one. So this would be in separation. We're gonna have this one. We can deal with this separately, or we can also separate them. So we can also do something called direct substitution to say whether you see we make direct substitution. This will become c to the power 4 plus c squared minus 1, and this is c squared plus 5. So this is what they've actually done here. So it's just to explain how to actually deal with limits. There's no problem with that. Let's now proceed to the next slide. In the next slide, we have the limit of a polynomial f of x where x approaches c may be obtained by finding the value of a polynomial at that c is true. What does this mean? It means when we have, let's say we have the limit when x approaches a of f of x, this will be the same as f at a. It will be the same as f at a. So what does it mean? When we are doing a direct substitution, it will give us the f of a. That is what they're actually trying to say. But if you look at this, it means when we have to find this following limit, we can do a direct substitution to say when there is x, we substitute by -3. Then -3, yes, it will give us 22 on the first one because it will be -3 squared 4 into -3 plus 1. This gives us 9 plus 12 plus 1, which is just 22. Or it's just the issue of doing a direct substitution. I think you are following the descent. Gentlemen, let's move on. Okay, then now the next one is the issue of limit evaluation continues. We can even do like deal with multiplication when we are solving limits, to say the limit when x approaches 3 on x squared into x minus 2. According to what they said, we can just like apply the limit on this one first and also apply the limit on the second one. This is what they've done. And they do. Another way would be to first expand. You say the limit when x approaches 3, we multiply this becomes x cubic minus 2x. Then we make a direct substitution. This will be 3 cubic minus 2 times 3, which is just what is this? Oh, no, 2x squared. I apologize, 2x squared. Yeah, this is 2x squared. So we're going to have 3 cubic minus 2 into 3 squared, which is still going to give us 9. Or we can even do a direct substitution straight away. There's no problem with that. There's no problem with that. So same applies with the other one at number B. We can either split them one by one, or we do a direct substitution. The answer will still be the same, a direct substitution. And in terms of this, we can still have, okay, yeah, in terms of this one, I think in second semester, you also be learning other method of finding limits, something called the L'Hopital's rule. The L'Hopital's rule, which says when we have something like this, we can also differentiate the numerator and the denominator, and you still get the same answer. You're still gonna get the same answer. Let's check something. Okay, let's check something here. Let me check. If we substitute by 2, 4 plus 4 plus 4, which is 12, divided by 4. Yes, the answer is 3. Let's now proceed. This is just the basics, guys. It's just the basics in terms of limits. Right, now let's move on. Limits containing rational function may be divided into 3 basic groups. Limits that are containing rational fractions may be subdivided. Now, let's first look on the first group according to what they said. In group number 1, they said, when the limit of f of x, when x approaches c of f of x divided by f of x, give us L, where f of c and f of g, like f of c and f of g, f of c is not 0. So they're just saying that the denominator is not 0 because any number divided by 0 will be undefined. So how do we deal with such case? Obviously, when we're dealing with such case, usually we can do something called direct substitution. Direct substitution means with what we have, we just substitute directly on each value of q. So this is what they've done here to get -3. I think you are following. So we can do something called direct substitution. I believe you are following. Then now, how about in the second one? Let's look on the second one. Group 2, it says, this time around, the f of the limit when x approaches c of f of c of x divided by f of g equals to L, where f of c this time around is 0. The denominator is 0, but the numerator is 0, but the denominator is not 0. And this is very important. Remember, if we do a direct substitution, and we find that when you do a direct substitution, where there is q substituted by 1, we get 0. And the denominator, we get 2. You see, 0 over 2, it's acceptable. It is acceptable. So when we have when you have 0 over a number, this is also acceptable. There are some cases where we are going to avoid when we have a number divided by 0, which we will talk about, which is called the indeterminate. All right, this is the case where the numerator is 0, but the denominator is not 0. So it is also acceptable when you do a direct substitution. Right, now, how about in group number 3? Group number 3, the numerator is not 0, but the denominator is 0. The numerator, it's not 0, but the denominator, it's 0. Yeah, this is what we need to avoid. Imagine when we have the following. When we have the limit of f of x over g, this we want it to be equal to L. But this time around, the numerator, f of the numerator, what do you mean by f of c? When we substitute by c, it gives us f at c, divided by c, it gives us g of c. This time around, f of c is not 0, but g of c is 0. Obvious, if g of c is 0, it means you're going to have a number divided by 0. And we know it is undefined in maths. It is undefined. Does not exist. So it means these are the things that we must try to avoid when we have a number divided by 0. So once we have a number divided by 0, it becomes undefined. But 0 over a number, it's correct. There's no problem with that. So which means we need to consider cases where we have a number divided by 0. It is undefined. If you look at this, it's like they've done a direct substitution. Where there is x, they substituted by 0. So 6 times 0 is 0, plus 9 is 9. So by 0, it gives us 0. You see, 9 over 0, it's undefined. And this is a red flag to say this is an example of something called indeterminate. Indeterminate or indeterminate. So we need to avoid that when we're dealing with limits. Once you do a direct substitution, then it gives you a number divided by 0. You must know that something is wrong. Something needs to be done. It means that the answer is not genuine. So you need to come up with other ways of determining the correct answer, which we're going to talk about later. Another thing is when we're exploring a non-existing limit, very important. Sometimes we might have a situation where we can find ourselves dealing with limits of a function at a point that makes a function to be undefined. This is very important, ladies and gentlemen, which we'll talk about. Imagine sometimes you're given this question in the exam to say, determine the limits of the following. Determine the limits of the following. It's just an example. And obviously, when we're given this, number one, we have to try to do a direct substitution. Direct substitution, it means where there is x, we're going to have 2 squared minus 4 over 2 minus 2. Then this gives us 0 over 0. You see, 0 over 0, this has to do with indeterminate or indeterminate. So you see that it is not allowed to have 0 over 0 as the answer. So this is a guideline to say once you get a number, divide by 0, or you get 0 over 0, or you get something called infinity over infinity. Sorry, I apologize. You must know that this has to do with indeterminate. So it means it's a way to tell you that that is not the correct answer. You need to come up with other ways. And the correct answer for this, usually when we have 0 over 0, it means you must actually try to factorize the expression. Somewhere, somehow, you must factorize. So what would be the correct answer here? The correct answer would be the limit when x approaches 2 of x squared minus 4 over x minus 2. Then we're going to apply factorization. If you look at the numerator, this is the difference between two squares. And having the difference between two squares means we're going to make two pairs of brackets. Factors of x squared is x and x. Factors of 4 is 2 and 2. Negative and positive algebra. Then you divide this by x minus 2. Then this becomes, then you divide these two. Then you're going to have the limit when x approaches 2 over x plus 2. Then when we do a direct substitution, you're going to substitute here by 2, then you're going to have 4. So it means 4 is the answer, not 0 over 0. So in the exam, in most of the cases, if you do a direct substitution and you are getting number over 0 or 0 over 0 or infinity over infinity, you must know it's something called indeterminate. And it means that is not the correct answer. You must come up with other ways of determining the limit of that function. Very, 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 very important. This is very important, ladies and gentlemen. Especially in the exam, they will give you these such questions. So you need to be able to know that once you have number over 0, 0 over 0, or infinity over infinity, it's also indeterminate. It is indeterminate. You need to avoid that. That's not the final answer. I think you've seen what I've done there. Let's now continue with the slides. According to the slides, like, yes, it's what I just said. Exploring a non-existing limit, which is group 3. Indeterminate form of 0 over 0. Very important. Indeterminate form of 0 over 0. You need to avoid this 0 over 0. You need to avoid that. So let's just go through this. They're saying if the limit of a rational fraction is being calculated as x approaches c, both the numerator and denominator approaches 0. So you're getting 0 over 0. So if you are getting 0 over 0, then the numerator and the denominator have something in common. Usually it will be x minus c, something in common, which is the x minus c. Then the rational function may be simplified. What does this mean? It means that wherever you have 0 over 0, you must know that the numerator and the denominator have something in common. And that something in common is actually the x minus c. Like when you say the limit when x approaches c of f of x over. So it means the x, if you take this, the x minus c should be both. There are somewhere they're trying to say that you need to factorize. Factorization, you must factorize somewhere, somehow. You must factorize. Very important. You must factorize, ladies and gentlemen. So now there is an example. According to the example, so it means in the exam, when you are given limits, ladies and gentlemen, what must you do first? All the time when you are given limits, you must do something called direct substitution. You make a direct substitution, which means you substitute directly to check what is your answer. Here they've done a direct substitution. Where there is x, substitute by 5, it gives them 0 over 0. You know, this is an example of an indeterminate form. And once you have 0 over 0, this is a guideline to say you need to factorize. Factorization, ladies and gentlemen. And this is what they've done. It means they know that there's something. It means the numerator and the denominator, they must have this thing in common. And how did they got this answer here? This is grade 10 work. The difference between 2 cube. Remember when you have x cubic minus y cubic. This will give us a binomial together with a trinomial. And how do you do that? Very important. If the sign says negative, it means the first binomial will have negative. So it means you're going to have x together with the y. So it means in the trinomial, already here we have x to the power of 3. We already used x here. It means we're going to have x squared here. And here we have y to the power of 3. It means we're going to have y squared here. Listen to me very well. The sign here is positive. It's straightforward. Because remember I said you must get a binomial. Binomial and trinomial. So which means to get the middle term, what you do, you just multiply these two. What is x times y? This becomes xy. But you be careful, if the sign is negative, you change it, becomes positive. That is what they've done. So which means when you have x to the power of 3 plus y to the power of 3, so it means this will become x plus y, because there's a plus. Then now here we'll have the x squared plus, always a plus, then the y squared. Then you do this. If you multiply these two, what is x times y? It's xy. So if it's positive, you change the sign, it becomes negative. So that is what they've done here. It means when they have x to the power of 3 minus 125, this is x to the power of 3 minus 5 to the power of 3. And this would become x binomial, x minus 5. Then this side trinomial will be x squared, because they used x, and y squared, always a plus. Then we multiply these two. 5 times x, this becomes 5x. But since the sign is negative, then we change it to be positive. That is what they've got here. So then after doing that, they've divided these two and they remain with this one. Then they've done a direct substitution, and their final answer is 75. 75 is their final answer. I believe you're following. Okay, let's move on to the next slide for the special limits containing square roots. Under this one, it says, in this case, we rationalize the denominator or the numerator. So this has to do with, apologize, rationalizing either the denominator or the numerator, depending on the equations. So it's either we rationalize the denominator or the numerator. So if you look at this, remember I said, once you do a direct substitution and you get 0 over 0, or infinity over 0, or infinity over infinity, this has to do with something called indeterminate. So now, according to what they've said now, initially they've done a direct substitution. Obvious, if you substitute here by 2, this will be the root of 4, which will just be 2 minus 2 over root 2 minus 2, which will just be 0. So which means 0 over 0. So this is an indication that you're dealing with an indeterminate. So it means something needs to be done. So since here we are having rational expressions, which means because of the sides, it means here they've done something called rationalizing the numerator, because the square root is at the numerator. So in terms of rationalizing, if you recall from the lower, okay, I apologize, guys. So as I was saying that in terms of rationalizing the denominator, one can actually do this. The denominator or numerator depends on the equation, right? We know that from the lower grade when we have, for example, 1 over the root 2 of 2. So here we're actually rationalizing the denominator. So we can multiply it by root 2 over root 2. This will become root 2 over root 2 times root 2 is 2. So what they've actually done here is that they are trying to rationalize the numerator, which means from the expression from this, they multiplied by the opposite of this one, which is the root of 2 plus, I'm saying the root of x plus 2 plus 2 here. So which means it's the opposite of obvious dividing by the same because this is already 1. Then after that, they have to multiply these 2. So which means it's going to be the root of x plus 2 minus 2 times the root of x plus 2 plus 2. Obviously, this is just a mere algebra. So we have root 2 multiplied by root 2. This will be x plus, I'm saying root x plus 2 times root x plus 2. It will give us this one. Then we have root x plus 2 times 2. This becomes 2 root x plus 2. Then negative 2 multiplied by the root of x plus 2. This will be negative. This will be negative 2 root x plus 2. Then lastly, it's negative 2 times positive 2, which will be negative 4. So as a result, this 2 will become 0, and we remain with x plus 2 minus 4. Obviously, 2 minus 4 is minus 2. So that's why this is what they got. And they multiply the denominators. This is what they've got. So you can easily see that the x minus 2 and x minus 2 will divide. Then we remain with this one. So according to what they've done here, they've actually done a direct substitution. So when they do a direct substitution, it means when there is x, they substitute by 2, then it means the answer becomes 1 over 4. So this is actually called the rationalizing the denominator or numerator. It depends with the equation that is actually provided. So this is what they've actually done here. Then now we can move on to the next slide. In the next slide, this speaks of the definition of limits as x tends to infinity. So according to what they are saying, they're saying if they're given if we let f of x be a defined for all sufficiently large real numbers. So this infinity actually has to do with a large number. This is the large number actually. So now when we say the limit when x approaches a large number actually. So according to this, they said f of x said to approach the limiting value L as x approaches infinity, provided difference between f of x and the L can be made as small as possible. So this is what the actual time to say, that when the limit as x approaches infinity, f of x will become L. So when the limit as x approaches a large value actually, f of x will become L. So if f of x is unbounded, unbounded means if we are actually having a condition where we are approaching this from the right or from the left. So which means that if the limit when x approaches a large number, the f of x will actually become large because this is actually a large number. But in the context of the limit where we're having 1 over x, this is very important. The limit when x becomes infinity, approaches infinity, 1 over x will become 0. What does this mean? It's actually saying that as we keep on increasing, if the x becomes bigger and bigger, if x becomes bigger and bigger, it means 1 over x will actually approach or become 0. For example, if we were to have, let's say we have 1 over 2, 1 over 2 is 0.5. But if we say 1 over 3, this is 0.33. So 1 over 4, this is 0.25. You can easily see that as the as the x is increasing, let's say we have 1 over 1,000. obvious 1 over 1,000, this will become, it will actually become 0, 0.0012, 0.001, 0.001 actually. So you can easily see that as the x increases, as the x becomes bigger and bigger, the expression 1 over x becomes 0. So it means if we keep on, let's say, into a million, you can easily see that the more x increases, become bigger. So it means this will actually become 0. So that is what they've actually said. They've actually said, and this is very important. This is very, very, very important when we are dealing with the limits that actually approaches infinity. So it's very, very, very important there. Let's just continue in terms of their generalization. Infinity, we're just saying big, actually the number becomes bigger. In this context, okay, if we look there, like they said, generally, if the limit when x approaches infinity, the limit when x approaches infinity of 1 over x to the power of n, then this will actually, this will become 0 for all n. This has to do this for all n greater than 0. So if we're using any value of n that is actually positive, then this will hold true for all value of n that are greater than 0. That is what they've actually said. So this is one of the most important notion under limit principles. So now, there's some special cases actually of limits. You see, remember I said the reason they spoke about the issue of limit when approaches infinity is that, remember we said during the principles of limit, if we have 0 over 0, or we have infinity over 0, or we have infinity over infinity, this has to do with indeterminate. So which means that when, according to some rules that they've said, the limit when x approaches positive infinity or negative infinity on x, this will either be plus or minus. So it means if x becomes bigger or becomes smaller, then the output will either be bigger or smaller. Same applies, the limit when x approaches infinity, positive infinity or negative infinity on x squared. So it means if we substitute by a bigger number, the answer will still become large. The answer will still become more. It will be positive. Why? Why can't they say plus or minus? Because this is x squared. So it means if you put a positive number or a negative number, the output will always be positive. So, but in terms of this one, the limit will become 0. And this is very important. Same applies with this. So it's very important that as long as you're having the denominator, but if we have, imagine we have the limit when x approaches 0, infinity of x over 2. So obviously this one will still become bigger, because you take a bigger number, you divide by 2, it will still become bigger. But if this one is at the denominator, then it will become 0. Because as the denominator increases, become bigger and bigger, the whole fraction will actually approach 0. So this is what they're actually trying to explain. And this is very, 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 very important according to what they've explained here. Then in some cases, like if we have, I think this is an example that they've done here, to say when you are finding the limit where x approaches infinity, usually you can do something called a direct substitution. Obvious, when you do a direct substitution, let me just try to explain it here to say, remember infinity, we are just saying, we are referring to a large number. So if you take a large number and you square it, what will happen? Obviously, a large number squared will still become large. And when you take a large number, you subtract by 2, it will still become bigger. So a large number cubic will still become larger, plus 3 times a bigger number will still become a bigger number. So end up having infinity over infinity. We know once you see this, it's called indeterminate. And in the context of these cases where you have, the limit is approaching infinity, it means here we need to take a common factor, particularly at the denominator. We need to take a common factor of the denominator here. So let me explain what is it that they've done here. Because they got infinity over infinity. So let me actually explain how did they got the, how did they took the common factor. If you look on the expression here, because we're having the numerator and the denominator, so what they've done is they took a common factor of x cubic on both the numerator and denominator. How did they do that? When one is taking a common factor, let's say we're having x squared minus 2. If we say we are taking a common factor of x cubic, it's like, in other words, it's the same as when you can say, after when you have taken that, you can take these two expressions, you divide by that x cubic, both sides. Why? Because when you multiply in by that, these two will actually divide and remain with that. So it means what they've done is they've taken a common factor of x cubic, and by so doing, it means they also divided by the x cubic on both. So as a result, these two, remember when we have x cubic, let me say x squared divided by x cubic, this will end up with 1 over x. So this is what they got here. And same applies with this one. And same applies here. When you take a common factor, if we have x cubic plus 3x, the common factor will be x cubic. And after taking it, we also divide by that. So we'll have x cubic divided by x cubic plus 3x divided by x cubic. They did not show this, right? Which means the final one would be, this would become 1, and this one, this will divide there. So this will become 3 over x squared. So in other words, then this will become 1 plus 3 over x squared. So this is what they've actually done there. So in terms of that, what they've actually done is, why are they doing this? They are doing this such that they want to apply the rules that they've explained before, to say, since these two are going to divide, then they will have to apply the limit on each. Remember, the limit on this, this will be the limit when x approaches infinity of 1 over x on this one, minus the limit when x approaches infinity of 2 over x cubic. Divide by, they've done the same on this, the limit when x approaches infinity on 1 plus the limit when x approaches infinity of 3 over x squared. I think in terms of the derivation, this will be 0, because you see the denominator, this also will be 0. So that is what they've shown here. And also this one will become 1, but this one will become 0. So that's why here we have 0 over 1, and 0 over 1 is acceptable. So it means the answer is 0. So that is what they've actually done. But you only do this way of taking common factor when you are dealing with limits that are approaching infinity, or when you got infinity over infinity. I think we'll look on the other examples. Right, let's now look on what they've done here. I think it's based on what I was just explaining here. To say, in terms of this, what they've done here, they've done a direct substitution. So what is the direct substitution here? It means where there is infinity, where there is x substituted by infinity, a bigger number cubic will become a bigger number. And when you take a bigger number, subtract by 8, this will become bigger number. Same applies. Bigger number squared minus 4 will become, we see, it becomes indeterminate, which means a common factor should be taken here. So let's check what is it that they've done here. So in other words, they've taken a common factor but of the denominator. We divide both the numerator and the denominator by the highest power of x in the denominator, So it means the common factor should be done at the denominator. So what they've done here is, it's like they've done this. They said they have x cubic minus 8. They're taking a common factor of the highest power degree, the highest power of x at the denominator all the time. So which means here they took a common factor of x squared. So if they took x squared, it means they will have to divide everything by x squared. But they did not show that. So by x squared, same applies at the denominator. Then they have x squared minus 4. This becomes x squared into, they do the same, x squared divided by x squared minus 4 over x squared. So you can easily see that this and this will divide them, they will remain with x. This is what they've done. Also with this part, and yet they will just remain with 1, also with this part. Then after they make a direct substitution to, it's obvious with this one, this will become infinity minus 0 over, this will become 1, this will become 0. So you see that with infinity divided by 1, obvious, this is acceptable. The answer becomes infinity. So it means they're taking a common factor at the denominator, but looking on the variable that is the highest power of x in the denominator. But you only do this method when you are dealing with limits that are actually approaching infinity, but on a condition where they are having infinity over infinity. Very, very important. So that is what they've done here. So same applies with this one. I just want to explain what they've done here. So in terms of this, remember we said we first do a direct substitution. With a direct substitution, let's check. So when we substitute by infinity, 2 times bigger number is bigger number plus 1 to become bigger number. So bigger number squared minus 4 is become a bigger number. And the square root of a bigger number is still become a bigger number. You see, it becomes indeterminate. So in that case, it means they have to take the common factor of the highest power of x in the denominator. And what is that? X squared. So what they've done is, let me just try to elaborate this. What they've done is they just said, okay, fine. They want to take the common factor of the highest power degree of x at the denominator, which is x squared. So it means with 2x plus 1, they wanted x squared here. So it means it will be 2x divided by x squared plus 1 over x squared. So obvious, this one will become x squared into the x and the x will divide, then they will have 2 over x plus 1 over x squared. Is it 2 over x? Okay, yes. So this will become 2 over x for now. Then they go to the denominator. The denominator, it means it's inside the square root. This is x squared minus 4. Then this becomes the square root of, remember they took a common factor of x squared. So this will become x squared divided by x squared minus 4 over x squared. So obvious, this will become the square root of x squared into, this become 1 minus 4 over x squared. But in terms of such, this can be rearranged at the square root of x squared times the square root of 1 minus 4 over x squared. And what is the square root of x squared? It's x. So it means here this becomes x times the root of 1 minus 4 over x squared. So as a result, when we combine this will be at the numerator. This will be x squared into 2 over x plus 1 over x squared over, this one will become x times the root of 1 minus 4 over x squared. So you see that here, it's only the x will divide with the x, so they remain with x. So if they remain with x here, it means now they will have to multiply in with the x inside here. So when they multiply in with the x multiplied by 2 over x, it becomes 2. Then times this with the x become 1 over x. That is what they've done here. So now they do a direct substitution, then they will get the answer. Remember, the limit of when x approaches the infinity of 2, this will become 2. This one we know it's 0, and this will be 0. So it will become 2 over the square root of 1, which is the final answer will just be 2. So this is what they've actually done here. So you take the common factor of the highest power of x in the denominator when you are dealing with limits when they're approaching infinity. When you got infinity over infinity, we know infinity over infinity is indeterminate. So that is what they've actually done there. So I'm just actually explaining what they've actually done here. Let's move on to the next one. So there's an exercise here. There is an exercise here. Like what I actually said. Let's just try to go through this. Then obvious when we have something like this, remember, when we make direct substitution, we get infinity over infinity. So we know it's indeterminate. So what do? I'll just try, we check the common factor of the denominator, the highest power of x, which is x to the power 4. So it means when we have 3x squared plus 1, this will be x to the power 4 of 3x squared over x to the power 4 plus 1 over x to the power 4. So at the denominator, we'll have the square root of 9 x to the power 4 minus 4, which will just be, remember, we take the common factor of the highest power of x, which will be x to the power 4. And as the norm, we take common factor and also divide by it. So this becomes the square root of x to the power 4 times the square root of, this will divide, then we're going to have 9 minus 4 over x to the power 4. So what is the square root of x to the power 4 over this x squared times the square root of 9 minus 4 over x to the power 4. So when we apply this, this will be the limit when x becomes infinity of the denominator. This will be x to the power 4 of, obviously, this will divide here when I have x squared. So it is 3 over x squared plus 1 over x to the power 4. Then we're going to have x squared here with the square root of 9 minus 4 over x to the power 4, if I'm not mistaken. You can easily see that x squared and x squared will divide, then we're going to remain with x squared here. So it means in terms of the application, also remain with this is they have to multiply in again. So this, you see, these two will divide, then remain with 3. And this also will divide with that, is going to remain with 1 over x squared over the root of 9 minus 4 over x to the power 4. And applying infinity, this will become 3, this will become 0. Square root of, this will become 9, and this will become 0. So we'll end up having 3 over the square root of 9. So which is just 3 over, square root of 9 is 3, so it means the answer is 1, according to this one. So it means you take the common factor of the denominator, the highest power of x at the denominator. Ladies and gentlemen, I believe you're following. Okay? I think I've not missed anything there. But you only do this method when you have infinity over infinity. Immediately when you have infinity over infinity, then you can apply this method. Right, then the other one is the issue of, the second one, what do we have? X cubic minus 8 over x to the power 4. So I think here what you do, we look at the denominator, we look at the highest, it's x to the power 4. So it means we take the common factor of x to the power 4 on both. Obviously, remember I said when you take common factor, also divide by it. So it's x cubic over x to the power 4 minus 8 over x to the power 4. Same applies here. X to the power 4, which is x to the power 4 over x to the power 4 minus 4 over x to the power 4. So now, by so doing, you can easily see that these two will actually divide because they're not in a square root. So with this, we have this x3, and this one's going to remain with 1 over x minus 8 over x to the power of 4. Divide by, this will become 1 minus 4 over x to the power 4. Obviously, when you apply limits here, this will become, if you apply limit, this will become 0, 0, 1, and 0. So we have 0 over 1, which will just become 0. So the answer is 0 there. Then now, the other one is number, I think I can leave out number 3 because the application is the same. Let's move on to the issue of number 4. Number 4 is to do with absolute value. So it says the limit when x approaches infinity of an absolute value plus absolute value of 8 plus x over x. And this is very important. Look, first of all, we need to understand something about absolute values. Remember, absolute values are non-negative. So it means the absolute value of x will become, if it's a, if the x is number bigger than 0. And the absolute value of x will become negative a if the x is negative. So which means here, we have one condition here. The x is approaching in positive infinity. So it means if the x is approaching positive infinity, it means the numerator will be positive because the absolute value of a positive will become positive. So it means this is the same as when we say the limit when x approaches infinity of just x plus 8 plus x over x. Why are we doing this? Because the x is approaching a positive, it's approaching a large number, which is actually positive. So the absolute value of a positive will become positive. So which means here we'll have the limit when x approaches infinity. And we'll try to solve this. This becomes 2x plus 8 over x. So since the denominator is having x, so we can divide everything by x. This becomes 2x over x plus 8 over x. So this will become the limit when x approaches infinity of 2 plus 8 over infinity. So we know that this will become 2 and this will become 0. So the answer will become 2. Very important. Very, very important. Then number 5 is the same as number 1. Same as number 1. So it has the same application, ladies and gentlemen. I think that is what they were actually expecting. Right, let's move on to the next question. Okay. Right, then in the next slide, this speaks of continuous functions, and this is very important. But let us go, let's look at the definition of continuous. So according to the definition, they said a function f of x is said to be continuous at a point where x equals to c if the following 3 conditions are met. If the following 3 conditions are met, what does this mean? Number 1, the function f of x should be defined at that point, should exist at that point. Again, the limit when x approaches c of the function should exist, and also the limit when x approaches c of f of x should become f of c. So if any of this condition is not satisfied, then the function is said to be discontinuous at that point. Roughly speaking, a function is said to be continuous if its graph can be drawn without lifting a pen from the paper. And it's true. A graph that is discontinuous, you can easily see, for example, if you talk about hyperbola, like in terms of the when we have y equals to 2 over x, so it means the asymptote will be y equals to 0 and x equals to 0. So which means the graph will look like this. So wherever we have a discontinuous function, it's where you find that when you are drawing the graph, you have to lift your pen. For example, if I draw, this is the first, you see, I'm lifting my pen, I'm starting somewhere. So this is an example of a discontinuous function. Why? It is discontinuous because in some points it's not defined. So it is not defined. But when you look at functions like this is an example of a continuous function. Because when I'm drawing it, I'm not lifting my hand somewhere. So I'm just continuing drawing. So, but whenever you are lifting the pen from the paper, then that is an example of a discontinuous function. Without lifting the pen, that would be a discontinuous. For example, when yes, like this is a continuous function. For example, if we were to sketch a parabola, if I have to do this, I did not lift any, so I continued drawing up until the end. So this is an example of a continuous So it is existing everywhere. So if it does not meet any of this, then it's said to be discontinuous according to what they actually explained here. Okay, right. Let's move on. Okay, continuous case. Right, there they're saying for f of x equals to x squared minus 9 over x minus 3, then it means this will hold true if x is not 3. Why? It means it's something that is to do with the domain. Why did they say the x should not be equals to 3? It's because if x equals to 3, if x equals to 3, the denominator, remember any number divided by 0, it will become undefined. So it means x shouldn't be equals to 0 because a number divided by 0 will become undefined. So it means you can use any number except not 3. But now, in the case of 6, it means here they're just trying to say that when we have x squared minus 9 over x minus 3, this will become x minus 3 times x plus 3 over x minus 3, and these two will divide. So it means it will become 6 when the value of x is 3. So that is what they're actually trying to say here. They're trying to say in terms of the continuous function. Right. I think they're repeating the same thing here. And now we can move on to the next one. Yeah. Again, it's finding the gradient of a curve from the first principle. I think I've already explained this, that first principle has to do with the derivative of a function. So it's on the same thing as what I was actually explaining. And I strongly believe this one you understand. This is first principle. And finding the gradient of the curve from first principle, I think this one you know from grade 12. I'm not going to spend more time on that. Same applies here. They're saying use, find and differentiate the following using first principle. We know when we use the rules of differentiation, the final answer, this one will become 3x squared. Then now, in the context of first principle, maybe we can try to look at the ones that are involving square root signs. Right? For example, if you look, I think this one you know from grade 12, even this one. Let's look at number 3. Obviously, with number 3, it means if you want to use first principle, you can say we know f of x is the square root of x. So which means you can get f of x plus h, which means where there is x, we will put x plus h. So we now write the limit f prime x is the limit when h approaches 0 of f of x minus f of x plus h minus f of x over h. What is the f of x plus h? Obviously, f of x plus h is x plus h minus f of x, it's square root of x over h. Obviously, you see now we're having the limit when h approaches 0 of the root of x plus h minus the root of x over h. So we have to rationalize the denominator because I'm saying the numerator here. So we multiply by the opposite of this, which is x plus h plus the root of x. Also divide by that. So it's x plus h plus the root of x. Then from here, we'll have to multiply the numerator together and denominators. So obviously, this is 2 pairs of brackets. So this one times this one will become x plus h. This one times that will become plus the root of x times the root of x plus h. This one times that will become negative root x times the root of x plus h. Then lastly, this one times that will become the negative x. The denominator, we're going to have x into the root of x plus h plus the root of x. And obvious, this 2, it's 0. So we're going to remain with x minus x. So at the numerator, we'll only have the limit when h approaches 0 of will remain with h only. And with the h at the denominator together with the x plus h plus the root of x. So this will divide, then we're going to remain with the limit when h approaches 0 of 1 over the root of x plus h plus the root of x. Then where there is h, we can now put 0. So this will become 1 over the root of x plus h, plus we put 0 here. So we'll have 1 over root x plus root x, which is just 1 over 2 the root of x. That is the answer. That is actually the answer. And another way, guys, to confirm this, is you can eventually use the rules of differentiation from grade 12 to confirm if this is the correct answer. Remember, we know when we have y equals to the square root of x, this is the same as x to the exponent of half. So we can make dy over dx. So it means the half will come down, so when I have half x to the power of half minus 1. And this will become half into times x to the power minus half. And we know with negative exponent, this is the same as 1 over 2 times x to the power of half. And we know the square root of half, it's root. It's just, so this is the same as 1 over 2 times the root of x, which is the same as the one we got here. But you see, rationalizing the numerator or denominator. So it means that number 3 and number 4, same application. 3 and 4, same application. But you must be careful here. You must be careful here because this is to do with fractions. This is to do with fractions, ladies and gentlemen. I believe we are following. I strongly believe we are following. Okay. Right. Just a minute. So number 5 is straightforward. Straightforward. If you understood grade 12 first principle, still the same application. So with number 4, I'll just start for you to say, okay, we have f of x. It's 1 over root x, which means f of x plus h, 1 over the root of x plus h. So when we substitute in the first principle, so this the f of x plus h will be 1 over, with the limit, 1 over the root of x plus h minus 1 over the root of x all over h. And here you must first simplify fractions. So it means this will be the limit when h approaches 0 of, you know how to simplify fraction. You multiply the denominator together, this will be root x together with the root of x plus h. And you multiply this will be the root of x minus the root of x plus h. Then divide by the h, this h here. And what you can eventually do, you can either change this to multiplication. Obviously, this will be the limit when h approaches 0 of the root of x minus the root of x plus h over the root of x into the root of x plus h times 1 over h. So we can do rationalizing the denominator. So it means here you will have to multiply by the opposite of that. So it will be root x minus root x plus h. Then you multiply by the opposite of that, root x plus the root of x plus h. Same applies at the denominator. There's an h, so it will be h root x times the root of x plus h times this one, root x plus h plus the root of x plus h. And you remove this, then, and also the denominators, then you eventually get the answer at the end. So I believe you are following, ladies and gentlemen. Okay. Right, moving on to the next question, derivative of a function using rules. So I think this is what I said earlier in the video to say you must be able to use the rules. For example, derivative of a constant is 0. We know derivative of a constant is 0. So that's why they said here, if f(x) equals to b, and b is a constant, obvious its derivative, which is called a gradient at a point, its derivative is 0. But when you have y equals to x to the power of n, so the n comes down and reduced by 1. So that is what they've actually said here. But the derivative of a constant, it's just like y equals to k f of x is just k, but with the derivative of f of x. For example, when you have y equals to x, so you see that is a function of x. So the derivative of 2x, it means dy over the x here. This will just be 2 times the derivative of x, which is just 1. So that's why it becomes 2. So it's very important to know the rules of differentiation as in relation to the first principles. Right. I think this one I've explained them in the first video, so we can pass this one. Then the next one is the issue of, you see, rules, differentiation rule, that this, when you are having two functions, you can differentiate them separately. So in terms of the example, I think this is what this is what they're actually trying to explain from grade 12. This is actually grade 12 what to say. When you have f of x equals to 5, the derivative of f with respect to x is 0. But we have this one, this will be 3x squared. But we have this, you cannot differentiate this, you must first rearrange it to become this one, then you start differentiating. This one is differentiable. And this one you can differentiate on each expression. Obviously, this one is 2x squared. This one will be 15x minus 1, which is this one. This will be 7x. Never say 7x. This one will be 0. But this one you have to rearrange it to be 4 over x to the power of 3. But there's a minus. It's negative 4x to the power negative 3. Then you start so this minus 4 into minus 3 of minus 3 minus 1. This becomes 12 x to the power negative. Then you come it down. It's going to be 12 over x. I think there's a typo here, if I'm not mistaken. It's supposed to be 12, if I'm not mistaken. Unless if it is 5. Yes, if it was 5 here, it would be 15. I think this has to be 12. I believe you are following, ladies and gentlemen. I'm just going through the slides, at least trying to assist those who are in their first years, who actually don't understand the slides, and they actually want to go deep in order for them to get good grades in their first year maths. Right, again, the exercise, there's an exercise here. I think you can go through it. It's just that there's some few things that are very important here, even though it's not introduced. There's a video that I've created in my YouTube channel for knowing how to find the derivative of sine and cos. For example, when you have y equals to sine x, the derivative of sine with respect to x is become cos x. But when you have y equals to cos x, the derivative of y with respect to cos, it's negative sine x. So this one becomes negative sine x. So in terms of, they said, find dy over dx using first principle. So they wanted to use first principle on each. So it means in this case, this one you can use it. I don't know if they wanted us to use the rules or the first principle, but you can also use the first principle to get the answer. Again, number 2, this one I think you know how to find the derivative. Because here it says, for example, it says if y equals to x squared plus ax plus 3, then find the derivative. Obviously, we're going to have dy over dx. This will become 2x. Kx, this is a, and this is 0. And now they said determine the value of a if the gradient of the function of this one is 2. So we know this represents the gradient, so we know it's 2. So when I say 2 equals to 2x plus a, no, it's 2x here. So then now, okay, it's 2x plus a. Then it says, determine the value of a if the gradient of the function at this is 2. So you see that this become 2 minus 2x comes to a. So it means we can write them in terms of a. Then another one, it says if they differentiate this with respect to r. So it means we want dA over dr. So we are differentiating with respect to r. So this was the n. We bring it down. So it will be 2 times 2 pi r to the power of 2 minus 1 plus. In terms of r, this will become 2 pi h. 2 pi h. Why? Because remember, in terms of the rule r, here the power is n, it's 1. We bring it down, we reduce by 1. So it will be r to the power of 1 minus 1, which is just 0. And we know any number to the power of 0 is 1. So it means the final answer would be 4 pi r plus 2 pi r h. So this is the answer. You can even take common factor to be 2 pi r. So this will remain with 2 plus h. So that is the answer. So you can practice using these rules of differentiation, and I believe you will understand this, but there's something that I actually don't understand here, because the question said, according to the statement, it says differentiate function using differentiation. So it means, I think here maybe they wanted just you to use rules of differentiation. So obviously, if we had to differentiate this using rules, this will be 3 sine 2t plus 4 cos 2t. Then we're going to use something called chain rule. This will be 3. Derivative of sine is cos, so it will be cos 2t. Then we differentiate this, which is just 2, plus 4 into derivative of cos is negative sine, but it will be negative 2t. Then we differentiate this to become 2. So it means the final answer would be 3 times 2 is 6. It will be 6 cos 2t, then negative 8 sine 2t. So this is the answer. But in terms of this one, this would be, if we were to differentiate in terms, because the rule says when we have y equals to e to the power of kx, the derivative of y with respect to x means the k, this will be k e to the power of kx. So it means as the answer here, this will be 3 e to the power of 3x. Then this one will be negative 5 into negative 2, because the k is negative 2, e to the power negative 2x. So it means the final answer will be 3 e to the power of 3x plus 10 e to the power negative 2x. I believe you are following there. I believe you're following. And I think it will also be covered in the next slide. But I think here they said they wanted us to use the first principle, the long method of finding the derivative from first principle. Okay, right, let's now move on. The other one is the summary of the gradients of function of some common functions. Like here they're just explaining that, like what I was saying, derivative of a constant is 0, derivative of x is 1, derivative of x squared is 2x, but derivative of x, the n comes down and reduced by 1. The derivative of e to the x is equal to e to the power of x. I think I've done a video. There's a video that I've done in terms of this derivative. Derivative of e to the power of kx, just k e to the power of kx. Very important, where k is a constant. Derivative of sine is cos, and derivative of cos is negative sine. But derivative of sine kx is just k cos kx, which means what you do, use something called chain rule. Chain rule says you differentiate outside. So which means derivative of sine is cos. You leave inside, which is kx, and you differentiate inside with respect to x, which will be k. So that's why this is the answer. Same applies with this one. But the derivative of ln, the derivative when you have y equals to ln x, the derivative of ln x it's 1 over x. But which means that when you have y equals to ln kx, what does this mean? It means the derivative of ln, also use the chain rule to say derivative of ln on itself, it's 1 over the function here. Then we differentiate inside. What is the derivative of this one? It's k. So you can easily see that the k and the k divides, then we remain with 1 over x. That is what they're actually saying here. But in most of the exams, sometimes they give you these formulas, but it depends with the universities and the program that you're actually doing. But where I'm 100% sure it's when one is doing national diplomas, like let's say engineering and some, then they actually provide. But when you're doing degree, they usually don't provide. So other rules for differentiating a function. So it means this is actually introducing the rules of differentiation for grade 12. So something called a product rule, which says when you have y equals to f of x, the product rule says you differentiate the first function and you leave the second one. Then the one you differentiated initially, you leave it and you differentiate the second one. So that is called the product rule, very important. For example, if we have these two functions have been multiplied to each other. So it means what you can have, I think there's a video that I've done for the product to say when we have y equals to x to the power of 3 together with sine 2x. You can call it f, the other one g. So it means when you make dy over dx, we can differentiate the first one, we leave the second one. And the one we differentiated initially, now we come differentiate the second one. So what is the derivative of the first one? 3x squared. So we leave g of x, which is sine 2x. And what is the f of x? X cubic. Now we differentiate this one. Obviously, the derivative of this one will be 2. It will be 2. The derivative of sine is cos. So it's 2 cos 2x. So which means the final answer will be 3x squared sine 2x plus 2x cubic plus 2x. So this is what they've actually done here. This they've actually done here in terms of the derivative. This is what, like, it's a product rule. This is actually they introduced product rule here, and this is very important in the exam, particularly when you are using, if you are finding a derivative of a complex expression which have been multiplied to each other, then you have to use product rule. The other one is other rules is called quotient rule. And this also important quotient rule. This has to do with fractions. And with quotient rule, it says when we're having a fraction of y equals to f over g, what you do, you just differentiate the numerator. You leave the denominator minus, and whatever you differentiate, you no longer differentiate it. Now we differentiate the denominator. Then the denominator should always be squared. That is according to the quotient rule. Quotient rule applies when we're having fractions, ladies and gentlemen. So if you look on the example here, what they've done, they said, okay, fine. In terms of this one, they said they let the numerator be f, numerator to be g. They know that if f of x is this one, g of x is this. What is derivative? Obviously, derivative will be 2 cos 2x. Then this one, the derivative of g, this will be 2x. Then they write the definition to say differentiate f, leave that. Then when they make a derivative is that one here. I think this has to be 2 here. There should be 2 here. Then this one is x squared. Then f of x is the sine 2x. And g of x is the 2x. So which means here, then this will become it means they've taken a common factor on both. You see, the common factor here is 2x because there's a 2 here. So if they take 2x, then it means they will remain with an x here with cos 2x. Then here they will remain sine 2x. I think it has to be sine 2x here. because from the expression it says sine 2x. Then with this one squared, obvious, squared will become that. So that is the answer. Okay. Okay, then the other rules is the chain rule, like the one that I was saying to say. Chain rule, it says when you have y equals to y of x. So when you have a y as a function of x, but you have x which is a function of t, it means if you want to differentiate y with respect to t, what you do, you make something called reparametrization. So this has to do with chain rule to say when you have dy over dt, what you can do, you can put dy here, divide, then come with here dt. So here you're going to put the same thing. So which is dx. So it will be dx on both, because this will end up dividing. But if you make, so you see, that's why we have dy over dx and dx there. So, but now dy over dx, we can get it dx over dt, because you see, y is a function of x, but x is a function of t. So, for example, if you look at what they've done here, this is called the chain rule. They just said now, let me just try to explain it. Okay, according to what they said, yeah. If you look here, it says, as an example, y equals to cos x. This is the function of x, which means if you have y equals to cos x, so it means here we can be able to find dy over the x only. And what is dy over the x? It's negative sine x. That's what they got there. But when you have x equals to t squared, we see x is a function of t, which means here we can get dx over dt, which will be 2t. But the question wants to find dy over dt. So it means we have to do something called the parameterization to say, okay, fine. When we have dy over dt, remember the y here, it's not a function of t, it's a function of x. So what they've done, they just said we have dy over times denominator also here is dt. So it means here we're going to put dx in there, dx. So it means we're going to have dy over dx times dx over dy. So they know this and they know that, and they multiply that together. I think there's a typo here. Oh, no, it's not a typo. It's not a typo because they've done a direct substitute to say, remember here the x is equals to t squared. So if you substitute here by t squared, it means the final answer will be that one. This is called chain rule. We actually use it when we have like when we want to find the derivative of y with a parameter which is not here. So it means this is called reparametrization. Very important. It's chain rule. Chain rule is very important. There is an exercise that actually required these two that required the use of quotient and chain. So if you look here, then here it says, I think there's a rule that they did not introduce here, the power rule. Okay, let's just go through this. So it means with this one, with the first one, because there is a fraction here, it means this will require a quotient rule. This will require product rule. This will require quotient. This will also require quotient. This will require a power rule. But it's a chain rule, but actually it's called a power rule. That says when we have y equals to a function to the power of n. So when you find dy over dx, the n comes down, then we leave what is ever it's inside, reduce the n by 1, then we go inside and differentiate. That is what they want us to use here, especially number 5. So which means with number 5, we can say when we have y equals to 7x plus 3 to the power 4, we can say the f of x is 7x plus 3. So it means when we have y equals to f of x to the power 4, we write the rule. It says dy over dx, n comes down, it's 4 of the f of x. 4 minus 1 is 3, then we differentiate inside. So let's do the substitution. What is the f of x? 7x plus 3 to the power of 3. But what is his derivative? His derivative will just be 7. So it means the final answer will be 4 times 7, which is just 28 into 7x plus 3 to the power of 3. This is chain rule. This is chain rule, but working hand in hand with the power of rule. It's very, very important. And these other ones is the issue of just using quotient rule. It's just using a quotient rule. And actually the chain rule is one of the most important. Was like, for example, if you look at in the first one, you can let this to be fg, this quotient. So now first of all, we just say, okay, quotient says differentiate f. We differentiate the f, its quotient. We leave the g minus, we leave the f, then we differentiate the g, and we divide by the g squared. So it means, what is the f here? The f, it's the derivative of sine is cos. G, it's e to the x, minus we leave gf, which is sine x. This derivative of e to the x is just e to the x, divided by e to the x, but in all squared. There's something common in here, which is e to the x. Let's pull it out. This becomes cos x minus sine x. And here we have e to the x squared of them. So you see that these two divide. So it means the final answer becomes cos x minus sine x over e to the x. There's a video that I've done for the quotient rule and product rule. Okay. Then now number 2, number 3 and 4, I'll not do it anymore because this requires quotient rule. I just addressed now. Then now how about this one? This one means it has y equals to 2x times the ln. So it has both f and g. So it's product. And product says you differentiate f, you leave the g plus, you leave the f. So you leave the f and you differentiate g. So what you can do, what is the derivative of this is 2? We leave this, it's ln x, plus we leave f, which is 2x, then we differentiate the ln. The ln is 1 over x. So it means the answer becomes 2 ln x plus this will divide the ln with 2. So it means it's going to be 2 into ln x plus 1. So that is what they got there. All right. Another one is the issue of the number 6. Number 6, it can also use minus 2t plus 3. We can also use chain rule to say this is the same as e to the power of f at t. And the derivative says, chain rule says when you're differentiating, you differentiate what is its outside e. So do just e to the power of f of t and times the derivative of whatever it's at the numerator. So which means this will be e to the exponent of negative 2t plus 3 times, what is the derivative of this? This is negative 2. So this is the final answer of the negative 2 e to the power of negative 2t plus 3. I believe we are following. I strongly believe you're actually following. Then the other one is chain rule is very important, guys. Same applies with the one G of A. I think this was supposed to say G of X. I think there's a typo here. It's just a typo. So this was supposed to be G of X, the function of X. It's ln 3x minus 2, which means we are dealing with f of x as a ln of f of G of, like we can call this. So you see that is a chain rule. It requires a chain rule to say what you do. You differentiate ln. What is the derivative of ln? It's 1 over f of x times differentiate what is inside, just f prime x. Then we're going to have 1 over, what is f of x here? 3x minus 2 times what is the derivative of the, which is just 3. So it means the answer will be 3 over x minus 2. I believe you are following. I believe you're following. So chain rule is very important. So it means in terms of chain rule, it says when you have a composite function inside another function. Composite function. This is to do with composite function. So if you want to calculate the dy over dx, what you do, you just differentiate what is outside. You leave what is inside. And you come outside. You differentiate what is inside. It's composite. Because we look here, we differentiate what is inside, which is the ln. Ln is 1 over whatever it is of. We leave what is inside. We differentiate what is inside. For example, if you look on, like when we have y equals to sine 7x. So this is a composite because it's a function inside another one. So when we say dy over dx, so it's like we're having f and we're having g. So what is the derivative of f of sine actually? The derivative of sine would be cos. So we leave the derivative of sine will be cos. So we leave what is inside times we differentiate what is inside. The derivative then becomes 7. That's what the answer becomes 7 cos 7x. I strongly believe you're following. Okay. Then the other one, higher order derivative. So this has to do with second derivative and third derivative. Recall that differentiating a function yield f prime x called the first derivative. If the first derivative is differentiable, it can also be differentiated again. So that's the derivative of the first is the second. So it means if you have, let's say you have f of x. So if you differentiate it first time, this is the first derivative. Second derivative, first the derivative. So this is the higher order derivative. That is what they're actually trying to explain here. So if you have something like this, I can remember when you have f prime x, this is the same as dy over dx. So it means when you have f prime prime x, this is the same as dy squared 2 here over this. So this is the same as second derivative. And this is the third derivative, same thing. I believe you are following. This is what they are actually trying to explain here. Okay. Now let's move on. Yes, it's like here they just wanted to check if you are able to calculate to determine the higher order derivative. For example, using the rules, we know when we have y equals to x to the n, its derivative then will come down and reduce by 1. But of a constant is 0 of kx is k. So if you look at this, first derivative, it will be 5x to the power 4. Then I think you know how to do this. Second derivative, third derivative. Fourth, it means we differentiate for the fourth time. So this will be 6, 120, 48. It's kx, this is 0. So this one is 120, it's kx. We know the derivative of kx is k. So it will be 120. This one is 0. But of this one, so it means even if we do the seventh, then it will keep on giving us 0. Because the derivative of a constant is actually 0. Here they were just trying to, they were showing you how to find the higher order derivative. Very, very important. Okay, let's move on. There is an exercise here. And the first one, it says, find the s over the t and the s squared over. So it means we are calculating first derivative with respect to t and second derivative. So this is straightforward. So it means we know ds over dt is the same as s prime t. So we're differentiating this thing with respect to t. But already it's not well written, we must rearrange it. S equals to 3t squared minus 2t to the power negative 2. Let's differentiate. This will be 6t. I believe you are following there. Then the other one will be minus 2 into negative 2. T of negative 2 minus 1, which will become 6t plus 4t to the power minus 3, which we can rearrange this as 6t plus 4 over t cubic. But if you want the second derivative, it means we can take it from here. So it means this will be 6, and this one will be plus 4 into negative 3, t negative 3, negative 1. So this will be 6 minus 12, t to the power negative 4, and the final answer will be 6 minus 12 over t to the power 4. So I believe you are actually following here. The second one says, if you have y equals to ax plus 2 squared, determine the second derivative. And the second derivative is 18. Find the value of a. Obvious, what must we do? It's either we do this by using power function or we expand it. We can expand it, this becomes ax squared. No, a squared x squared plus 4ax plus 4. I believe you're following. Because multiply this with this, it becomes this. This one is 2ax, which is 4, then plus 4. So let's first find first derivative. So when I say y prime is the same as dy over dx. So we'll have dy over dx. So we're differentiating at x. This will be 2a squared times x plus 4a because kx is plus 0. Then let's make second derivative. Second derivative becomes 2a squared. This is 0 because there's no x here. So it means this is equals to 18 according to what they said. So we're going to have 2a squared equals to 18 divided by 2. It means a squared equals to 9. So it means the a will either be plus or minus 3. Or if we do not want to expand this, we can use the power function to say this is the same as ax plus 2 to the power of 2. So the y prime will be 2 into ax plus 2. and we reduce by 1, become 1 times, we go inside, this is A. I believe you are actually following. Then, because if we multiply this will become 2a squared x plus 4a. See, it's the same as this one. When we do for the second time, it will give us the same answer there. Very important. Very, very, very important. Okay. Can also do the other one on your own. Then now, then like number 3, it says, if S is this one, find the value of t for which the derivative of this is 0. And also for which the second, so you see, here you just say the S over the t equal to 0. So let's differentiate this. This becomes 90 squared minus 90t plus 36 and equate this to 0. You see, there's a number that goes into this. So this will become t squared. You divide by 9 throughout. This will be 10t plus 4. I don't know if I've done it wrongly. Okay, let's check. Oh, no, it's fine. So this become 3 by 3. 3 by 3. It's 9. Oh, this is 60. My mistake, guys. I can easily see with this something wrong. So this is 60. It's not 90. It has to be 60 because if we bring this will be 60. And if we divide everything by, it means we're not going to divide by 9, we'll divide by 3. So let's divide everything by 3. So this will be 3t squared minus 10 plus 12. This will be 12, apologies. This will be 12 equated to 0. So we can try to factorize. So we have 3t and t, negative and negative. Let's check. We want 10, so it means I'll put 4 here. No, not 4. Because it will be 12. Yes, it's, let's check here. 3 times 3, it's 9. This will be 12. I don't know if, so it means it will require a quadratic formula. Let's check. No, man, I said, why did I wrote, okay, apologies, guys. Something's wrong. It's supposed to be 60, not 60, because 3 times which is 60. So this will be, we look for a number that goes into 9, 60, and 36 is 3. So it means there it will go 20 times this one. And this one will be 12, yes. Then it means here we'll have, because we want minus 20, and we're gonna have, let me check here. If I put 12 by 3, so means I can have to use 6 by 2. Yeah. 6 by 2, not 12 by 3. I apologize. So this will be 6 by 2. So it means it will be 6 by 2 instead of 12 by 3. So you have 6 and 2, because this will be this one minus 18. So minus 18 minus 2, it's minus 20. So it means t can either be 2 over 3 or t can either be 6. So we'll do the same for the second. So it means we differentiate it again and equal to 0. This will become 18t minus 60 equals to 0. So with this one, it will be 60 divided by 18. So it means it will have 18t equals to 60. So it means this will become 10 over 3. I think this is what they're actually saying here. Yeah, I believe you're following. Okay. Okay, then let's move on. Application of derivative. This has to do with checking whether the graph is increasing or decreasing. So according to the definition, they say a function y equals to f of x. It's said to be increasing over a certain interval of x if y increases with increase of x. That is, if x1 and x2 are any values in a given interval where x2 is a number that is bigger than x1, then it means the f of x2 is bigger than f of x1. Also in the case of decreasing. So for example, if you look at this, it's increasing because if you have x1 and x2, it means the value of y when x is x2, it means f of x2 will be greater than f of x1. And also this has to do with a line, a function that is actually increasing its gradient at that point. The gradient at that point is bigger than 0, it's positive. So this has to do with first derivative. So this is what they're actually explaining here. Because a graph that is increasing or a function that is increasing has a positive gradient at a point. So now, in terms of that, using the application, you see, it's what I was actually trying to explain to say, if the derivative of a function is bigger than 0, if the gradient at the point is bigger than 0 for all values of x which are bounded there, you know that function is increasing over the interval. But if the gradient at a point is negative, then you know the function is decreasing. So these are the conditions that makes like a graph to increase or decrease. So it means if the gradient is 0, it means the graph or the function is constant, is stationary. It's not increasing and it's not decreasing. It's just stationary because the gradient is 0. So now if you look at this, say find the value of x for which the function increasing or decreasing. Obvious. If one for increasing, it means the derivative of x should be bigger than 0. And when we differentiate this, it will become 2x minus 2 bigger than 0. So it means when you solve for x, this is inequality. So it means x should be bigger than 1. So it means if x is bigger than 1, the graph will increase. It will increase on this graph. And by the way, this is a parabola and it has a smile face. So it means where the value of x is bigger than 1, the graph will increase because actually making the gradient where here it is where the graph is actually turning. So if you wanted to know the value of x where the graph is turning, you're going to say f prime x is 0. So which will be 2x minus 2, 0, which means x is 1. So it means when x equals to 1, it's where the graph is not increasing. So it means anything above that, the graph is increasing. But anything below, the graph is actually decreasing. That is what they're actually trying to explain here. So it's very important to know the conditions that causes the function to increase or decrease on a function. That is what they're actually trying to explain here. You can easily see that this is what I've said that you see they said you have to calculate the gradient function for increase implies that this is bigger than, so it's increasing for all. So it means increasing when x is bigger than 1. Or you can say from 1 up until infinity. Same applies with this one. So this is what you need to know. So the conditions for the increasing or decreasing. I believe you are following. Let's move on the other one, to the other one. So here it says determine the value of x determine the value of x for which f of x, x cubic minus 3x is increasing or decreasing. So we're going to do this. We'll say, okay, fine. The function is increasing when the gradient at that point is positive bigger than 0. So it means you have to differentiate the function bigger than 0. Let's differentiate. This becomes 3x squared minus 3 bigger than 0. We can divide everything by 3. This becomes x squared minus 1 bigger than 0. Then this becomes the difference between two squares. So we have x and x, 1 and 1, minus and plus. Then you get the critical values. This becomes x equals to 1 or x equals to -1. When you construct a number line, this will be -1 and 1. So since this is a parabola, smile face, so it means we have plus, minus, plus. Because we're looking at this, if we take a number bigger than 1, substitute here, the answer will be positive. Between it will be negative, then below it. So it means the answer will be x. If x is less than -1 or x is bigger than 1, that's why the graph will increase. So it will increase where x is bigger than, it's less than -1, and where x is bigger. So where x is less than, so it means where the x is less than -1 or where x is bigger than 1, that's where the graph is going to increase. But when the graph, it means in other cases, it means is the condition where it's going to decrease. So there's no need to solve this, because if for decreasing, it means the derivative will be negative. So we're doing the opposite. It will be 3x squared minus 3 less than 0. We divide by 3, it's x squared minus 1 less than 0. And we factorize its inequality. So it's x and x, 1 and 1, minus and plus. So critical values, it's x1 or x is -1. So you still see that we still have the same application. So it's plus, minus, but we want where it's negative now. Negative means where there's a minus. So it isn't, so it means the graph will decrease between -1 and 1. So it means if we were to sketch, remember the cubic has its own turning point. And to get the turning point, it means the graph will turn at x equals to 0 and x equals to 1, and also at x equals to -1. Why am I saying this? Because where the graph is going to turn, the gradient is 0. So you see that when we have 3x squared minus 3 equals to 0, divided by 3, and this become, you see, you're going to have 1, a plus. Actually, when you put this, you're going to have a plus or -1. But we know when the graph is like this, means it first have a set face and a smile face. So you can easily see that here. That's why we have we have 1 here. And here, it means if we were to draw a number line, the x equals to 1 is here. And even here, the x equals to -1 is here. So you can easily see that the graph from anything below -1, anything below -1, the graph will increase. The graph will increase here and also increase here. But between -1 and 1, just between here, the graph is decreasing. So, but at this point, this is where we have a turning point. So this is the shape of the graph actually. Because they said you must also sketch. Okay, I believe you're following here, guys. Okay, so it's all about what we have actually learned from grade 12. That's why I'm saying whatever you learn from grade 12, you're also using it. Algebra, inequalities, calculus from grade 12, it's also applicable here. So it's very important to understand. This is a cubic function. All right. Then the next one, it's, you see, this is what they've done. It's just that they've used the table method, but the output is the same. See that they're saying the graph is increasing So if you recall from the number line, it's one the same thing. It's just that they use a set notation. So to say, if it's between -1 and 1, like what I said, remember I said this side it's plus, minus, plus. So it means anything less than 0, -1, or anything above. That's what they said this from negative infinity straight to -1, and from 1 straight to infinity. So but between this is where the graph is actually decreasing. But we know the graph will have its turning point at -1 and 1. So that is what they also determined the y value to say when x is -1, the y value is 2. When it's 1 is -2. So they already got the turning points to sketch the graph. So that is what they've actually done there. So you already have seen the conditions where the graph is actually turning. Then now from here, they will have, they even determine the x-intercept. Oh, you see, that is what I actually intend to say. The graph will also, like anything less than -1, it will increase. Anything above 1, it will also increase. They determine the x-intercept also. You see, increasing, but in between is decreasing. So this has to do with gradients. But where the graph is turning point, it's turning. The graph is not increasing or decreasing. It's constant, it's stationary. So the application of derivative concavity, I think this one I've explained that it has to do with second derivative test. I've explained with, you see, remember I said when you have, if the second derivative derivative is bigger than 0, you have a concave up. But when you have a second derivative less than 0, you have a concave down. So you see that concave upwards applies when second derivative is positive. Concave down applies when the second derivative is negative. And where we have a concave up, there is always a minimum turning point. Where there's a concave down, there's always a maximum turning point. I think I've explained that in the at the start of this video. So I strongly believe you are following, ladies and gentlemen. So here, this is just a question to say, determine the open interval values of x for which the graph is concave up or concave down. So what we can do here, it means we have to do first derivative and second derivative. We look at the first derivative, it means here they've done first derivative, then second derivative, it means it requires quotient rule because it's now a fraction, f and g. So that's what they've done here, to say they differentiated this one, which is that they left the denominator. And then for concavity, first of all, this, if we do this, this is a point of inflection. Then now, from here, they wanted to know what is the value of x where we have concave up or concave down. So due to time, I'll just try to summarize it in terms of this one. Wherever you are struggling, reach out to me, and I will be willing to assist in terms of concavity, in terms of concave up or concave down. Actually also determine the local minimum and the local maximum turning point. For example, if you look at this, it says determine the local maximum and the local minimum values of this. Remember, this is a cubic function. And how do you do that? It means, first of all, we'll have to do a first derivative. This is 3x squared plus 4x minus 4. Then we do the second derivative. This would be 6x plus 4. Then first of all, because we want to know local maximum, we have to get the turning point. And we know where the graph turns, the graph is 0. So we'll equate this to 0 and solve for x. Then we're going to have 3x squared plus 4x minus 4 equals to 0. And I think we'll make two pairs of brackets here. So we'll have 3x and x, 2 and 2, plus and minus. So let's confirm 3x squared plus 6x, which is fine. So it means the x is 2 over 3, or x equals to negative 4. So I wanted you to know between the x equals to 2 over 3 and between the x equals to minus 4, which one will be at the maximum and which one will be at the minimum. What to do? We substitute this into the second derivative. So remember our second derivative is f prime x, it's 6x plus 4. So let's substitute, let's start with 2 over 3. 2 over 3 will be 6 into 2 over 3 plus 4. This will become 4 plus 4, 4 times, oh, this is 2, so 2 times 2, it's 4. So this becomes 8. So you see that this value is bigger than 0. The second derivative at 2 over 3 is giving a number that is bigger than 0. It means the second derivative at negative 4 will actually be negative 8, which is less than 0. We can even convert because this is 6 into negative 4 is negative 8. Okay, it's not giving us, oh, it's okay. So we'll have minus 6 times minus 4. Oh, it's not minus 4. I apologize. That's why I'm surprised. This should be 2. This should be 2, not negative 4. This should be negative 2. So we have negative 2 here. So with negative 2, we'll put negative 2 here. That's what I'm saying, it will give negative. It must give us same values actually. So we'll put negative, so it's going to be 6 into negative 2 plus 4, which is negative 12. Which is negative. You see this negative, and we said we know that when second derivative is bigger than 0, we need to have concave up. And at the concave up, it's where we have a minimum. And when the second derivative it's less, we have concave down, and we have this. So it means the maximum is it's at x equals to negative 2. So it means when x equals to negative 2, that's where we have a local maximum, because it's given when we substitute into the second derivative, it's becoming negative. And when x is 2 over 3, that's where we have a what? A local minimum. So which means if you want to determine local minimum, so it means we take these values, we substitute them into the original equation to get the y value. So we already know which one is at the local minimum and which one is at the local maximum by using second derivative test. So second derivative test is very, very, very important. If you don't understand something, you kindly reach out to me. I'm just trying to explain some key concept that will enable you to get good marks in your first year mathematics. Very important. Like what they've done here. Remember when you're calculating the turning points, you differentiate and equate to 0, because where the graph tends, the gradient is always 0. So what they've done here, they just, you see, they've done the first derivative and they solve for x. You see, they got 2 over 3 and negative 2. And after that, they also determined the second derivative to check the nature of these turning points. Then after that, they substituted by 2 over 3 and negative 2 when there is x. You see here, they got that when they substitute by 2 over 3, the answer is positive, even though they did not show the answer. The answer is positive because it's where we said second derivative, it's 6x plus 4. So when you substitute, then it gives us 8, which is bigger than 0. This is what they've done. And we know when the second derivative is bigger than 0, it means the graph smiles. It means that we have the minimum. So you see, it's a local minimum. So add x over 3. So which means its y value, we have to substitute this into the original equation, where they got negative 25, negative 256 over 27. Same applies with this. This will be the local maximum, where when they substitute into the ordinal equation, they got 0. So it's very important. So it means second derivative test we're actually using it to check the nature of the turning point, which one will be at the maximum and which one will be at the minimum. So these are the things that you need to actually understand. So this is the end of the session, and I believe you are following. For example, if you wanted to know the local maximum and the minimum, what do we do? First of all, we'll have to make the h prime x equal to 0 to get the turning point. So we'll have 3x squared plus 4x minus 4, which will still be the same as the one that we got. So it means I'm not going to do this. Maybe let me do the first one or the second one. Because the first one will require a quotient rule. We'll have to do a quotient rule first. For example, if we were to look at the second one, we can either multiply in, this will become x cubic 6x squared plus 9x. So let's make a first derivative and equals to 0 to get the turning point. X cubic 6x squared, this becomes 3x squared minus 12x plus 9 equals to 0. Let's divide everything by 3. This will give us x squared minus 4x plus 3 equals to 0. 2 pairs of brackets, x, 3, 1, negative and negative. So we have x equals to 3, or so these are just the x coordinate of the turning point. So we want to check which one is at the maximum and which one is at the minimum. So we have to do a second derivative test. And to do second derivative, I continue from here. This becomes 6x minus 12 because this is 0. So let's now substitute. Where there is x, we put 3 first. 6 times 3 minus 12. 6 times 3, it's 18. 18 minus 12, it's 6. Then h prime at 1, we put 1. This will be, is it 1? 6x minus 12. Yes, and when we put 1, this will be 6 times 1 minus 12, which will be negative. You see, this one is bigger than 0, and this one is less than 0. And we know when the second derivative is positive, the graph smiles, negative side. So this is the maximum, and this is the minimum. So it means it will be at the minimum at x equals to 3, and it will be at the maximum at x equals to 1. So already we need to go to get the coordinates. So what do you do? We substitute by 1 here where there is x. So if we substitute by 1, this will be 1 squared minus 6 times 1 plus 9. So it means the coordinate for the first, where we have a maximum turning point will be at 1 and 4. And the minimum turning point will be at, so now we substitute by 3 here. So it will be 3 into 3 squared, which is 9, minus 6 times 3 plus 9. Then this gives us 0. So it will be 3 and 0. So minimum will be at 3 and 0, maximum will be 1 and 0. And by looking at this graph, you can easily see that since it's cubic, it's positive, that means the graph will be like this. So you can easily see that when you draw a number line, the maximum will be at 1 and the minimum will be at 3. So where the y value is 4 positive, this one is, so it means actually the x-axis is here. So I believe, no, that's not here, sorry. So it has to be here, it's just that this one is touching. So it means it's touching this, yes. So it means the graph will actually, but there's no need to draw it. I'm just actually explaining it. So it means the graph will be like this. It will move like this. Something like that. So this is 0. Oh, but in the opposite way. No, this side, not this side. Okay. So it means it will be something like this. So the graph will actually, it will touch the y-axis, then you'll have something like this. Yes. Because here it will be 1 and minus 4 at the maximum. And this will be 3 and 0. So you can practice on your own, and wherever you are failing, you can kindly reach out to me. Remember, I'm just addressing, I'm not saying, I'm just explaining to actually assist those who are actually struggling in understanding some of the concepts at the university level, and also giving compliments to the two doctors who actually came up with these lecture slides, um, and everything. It's superb. I believe it will assist most of the candidates. Here you'll have to do first derivative using quotient rule, then also do it for the second time again. It's just that due to time, it will take me, it will be long, because I will have to first do the first one, which means we differentiate this, which will be 1 over x, then leave this one, which is x minus, then leave this one, and differentiate this, which is 1, then define the squared. So you see that this will become, the numerator will become 1 minus the ln of x over, then we do the same again for the second derivative. But first you can equate this to 0 to solve for x. So you're going to have 1 minus ln x over x squared equals to 0, if I'm not mistaken. Okay, then obvious, this will be, when you cross multiply, you're going to have 1 minus ln x equals to 0. So 1 equals to the ln of x. To get rid of the ln, you need to exponential the power of 1 equals to exponential. So it's going to be ln of x equals to 1. Then we put e to the raise. Obviously, this is x. It's e. So we know the e. But already we're getting one answer here. So since we are getting one answer, we can either do the second derivative, because with the first derivative, what are we getting? 1 minus ln x over x. So it means with the second derivative, we square the denominator. This is, oh, by the way, it was x squared. So it means this will be x squared to the power of 2. Then we differentiate this. This is 0 minus 1 over x times this x squared, and some stuff.